Welcome to this beginner level course where you will learn how to build a complete web application step by step using ASP.NET Core and the C# language. My name is Julio Casal, and I spent the last decade building all sorts of cloud-based applications that handle millions of requests every month. By the end of this course, you will have mastered all the skills necessary to start your journey into C# backend development, even if you have never created a web application before. So let's get started by taking a quick look at the application that you will build across this course. Imagine that your team has been asked to build the game catalog section of your company's video game store. The front-end developers already took care of building the web UI for this game catalog, where administrators can manage the information about all the games offered by the store. Now you, as the backend developer, need to figure out a way to stand up the backend that will provide all the game data required by the frontend. The game data lives in a relational database with tables for games and game genres. And to let the frontend access all this data, you will create a new REST API that will provide all the standard operations to create, list, update, and delete games. In this course, you will create this backend from scratch using the latest innovations in ASP.NET Core and C#. If you're interested on the front-end portion of this system, please check out my Blazor tutorial, linked to this video, where I cover how to build that part in detail. Now, creating an ASP.NET Core backend involves understanding multiple concepts, techniques, and patterns that I'll cover in detail in this course. You will start by learning how to create, run, and debug your first ASP.NET Core application from scratch. Then, we'll go over the core concepts behind REST APIs and how to quickly implement the traditional CRUD endpoints in an ASP.NET Core API. As you implement your REST API, you will also explore the use of data transfer objects, or DTOs, to define the contract between your API and the frontend. Then, you'll see how to use extension methods and route groups to properly organize your API endpoints. You will also spend some time trying out invalid inputs to learn how to ensure they are properly handled by your API. Next, you will introduce real database support via the popular Entity Framework Core ORM framework, which is included with the .NET platform. This will also be a good time to explore the ASP.NET Core configuration system, which will help you avoid hard-coding important configuration details in your C# code. Next, you will explore in detail the dependency injection design pattern and how service lifetimes work in ASP.NET Core applications. You will also learn here how to properly map your entities to DTOs to ensure you maintain the data contract with your frontend while keeping a flexible data model. You will complete your REST API implementation by introducing the asynchronous programming model, which will ensure your application uses the web server resources in the most efficient way. And to close, I'll show you how your REST API can nicely integrate with the frontend to light up a modern user experience. In order to take this course, you should have some basic knowledge of C#, Java, or a similar object-oriented language. You should also know the essentials of web development, and it would also help if you have some experience with relational databases. However, this is a beginner-level course, so you don't have to be an expert on any of these topics, since we write every line of code from scratch and everything we do is explained in detail. In terms of the software prerequisites for this course, you will need to download and install the following: the .NET Software Development Kit, or SDK, which includes everything needed to build and run .NET applications, and Visual Studio Code, a lightweight but powerful source code editor that you will use to write, build, and debug your code. Please go ahead and install these tools now using the URLs on screen if you don't already have them. You will also need a few VS Code extensions, but we'll get back to those later in the course. With the .NET SDK and VS Code installed, let's see how to properly configure your development environment. Let's see how to configure Visual Studio Code to work with ASP.NET Core applications. Now, Visual Studio Code is a very powerful code editor, but we're going to need a few additional extensions to improve our C# coding experience and also to be able to interact with our REST API. So the first thing that we're going to do is just head into the extensions view right here. So let's go into the extensions view, and then let's go ahead and look for the C# dev kit. So you want to just type C# here, and the first hit is going to be likely the C# dev kit. So this is the extension that you want to install. So just go ahead and click on install on this one here. And the dev kit is really an extension provided by Microsoft that is going to overall improve the experience of coding C# and working with C# projects in Visual Studio Code. Now, this extension does not install just one extension, so let me show you that. This actually installs a few extensions. If I just clear C# here, this is going to install, to start with, the C# extension, this one over here, which adds the base language support for C# inside VS Code so that it can recognize all of the C# syntax. Of course, it also installs the dev kit itself, which is the extension that provides additional improvements to VS Code, things like, for instance, a solution explorer, so that you can more easily manage your C# projects and create C# files, and also so that you can run and create test projects directly in VS Code. All of that is included with the C# dev kit. It's also going to install, as you can see down here, integrated code for C# dev kit, which what it does is just adds a little bit of AI-assisted development as you're typing your C# code. And lastly, it also installs the .NET install tool, this extension over here, which what it does is really a tool that provides the .NET runtime or the .NET SDK to other extensions if they need to. And so that is what we need in terms of C# development. Now, the next extension that I recommend you install is one called REST Client. Now, this extension, this is an open source free extension that I'm going to just go ahead and install, by the way. So let's go ahead and install it. And this is going to improve the way that we can interact with our web APIs or REST APIs directly in Visual Studio Code. And we're going to see that later in the tutorial. And the last extension that you should install is an extension for SQLite. Okay, so it's going to be the very first one over here, SQLite by Alex CVCC. So let's go ahead and install it. And this is going to allow us to very easily interact with the SQLite database that we're going to be using across the tutorial. All right, so yeah, so those are the extensions that we're going to need. And so let's now close this, and let's close this pane over here. Now, the next thing that we should do is to make sure that, well, that .NET has been properly installed in the machine, right? Just like a safe check. So let's go ahead and open our terminal. And to do that, what you can do is just go into your menu bar, terminal, new terminal, over here. And by the way, a quick shortcut for this, at least on Windows, is either Control tilde, right? You type Control tilde, is going to toggle that terminal for you. Or you can also do Control J. It's a nice way to open and close this terminal very easily. All right, so now in terminal, what you want to do is just verify that .NET is in the box. So just type .NET -- version, and that's going to print out the version of the .NET SDK that you have in your box. You can also do .NET -- info, and that's going to give you even way more information about everything that is related to the .NET SDK installation that you have in your box. And with that done, let's see how to create our web project. Now, Visual Studio Code, and by having the .NET SDK installed, there are a couple of ways to create your .NET projects. And the first way is directly from the terminal. So here in the terminal, let me go ahead and just clean this very quickly, CLS. One way that you can do this is by using directly the .NET CLI or command line interface. So all you have to do is just type .NET, and then you can type new, and this allows you to pick from a series of templates to create your projects. Now, with what templates do we have available here? All you have to do is just put here list, hit enter, and this is going to give you the full list. And let me expand this. This gives you the full list of all the possible types of applications that you can create with your local SDK installation. All right. So for instance, if you wanted to create a web project, you could choose this one template here. For instance, SVNet Core empty web, right? That will go ahead and create a fairly empty .NET web project. However, since we installed the C# dev kit, there is another way that you can also do this. So let's go ahead and minimize the terminal over here. Let's actually close it for a moment. And what you can do is just use your command palette by going into your menu over here. So just go into your menu, into View, Command Palette, right there, which, by the way, you can easily access by just doing Ctrl-Shift-P, which I'm doing right now. Ctrl-Shift-P. We'll go ahead and open this command palette. It's super useful. There are many commands available here across the many things that Visual Studio Code can do. Now, in this command palette, all you have to do is just look for .NET, and then look for New Project, which is the first option over there. Click on that one, And this is going to go ahead and open up the list of available projects to install. So the list is not as comprehensive as with the .NET CLI, which is why I like to always know how to do things via the CLI and not just via these different menus. But here we have a handy way to do this, right? So what we want to do is to pick a template that lets us create a project for a REST API. Now, we could go ahead and choose the ASP.NET Core Web API project template over here, which is what you would use if you're more experienced with Web API development. But if you're new, what I recommend is that you start with the ASP.NET Core empty template over here, because that will go ahead and create only the minimal set of files and configurations that are needed to get started. And then you can learn slowly how the different additional pieces are going to fit together, right? Like Lego pieces, you're going to learn how to stack each of these pieces and what exactly is each of these pieces doing, right? As opposed to start with a bunch of files and configurations that you may not understand at the start. Okay, so we're going to go ahead and create a brand new application with ASP.NET Core empty web. So let's click on that one. And this is going to ask us to choose a directory where we want to create our project, right? So I'm going to be using my D projects directory here. You can use any directory in your machine. But what we want to do here is to create a folder that represents the project or the application that we're going to be working with. In this case, what we're doing is creating an API for a game store, and specifically the API to retrieve or to manage the list of games, the video games in our game cap. So because of that, we're going to be creating a brand new project over here, a brand new folder, sorry, which is going to be named Game Store. Okay, so I'm going to double click on that one. So we select the Game Store directory. I'm going to click on Select Folder down here, Select Folder, and that is going to make it so that VS Code opens that directory, turning it into the workspace where we're going to be creating all of our projects. Now, from here, the last thing that we have to choose is the actual name for the project that's going to represent, in this case, our API, our Game Store API. So for that one, let's go ahead and type GameStore.api. Let's hit enter. And now VS Code opens, like I mentioned, our directory, our Game Store directory. And as you can see on the left side, we now have our brand new Game Store project created over there, alongside with a solution, which is the one that we can use to group the different projects that build our application, right? Now, one thing that you should notice is that there's not one, but two ways to explore the files that got created for your project. Now, the first way is, of course, the one that we are seeing right here, right? This is known as the File Explorer, and this is showing all of the files, the physical files that compose our current project, right? But there's also this other explorer, but you can see down here is known as the Solution Explorer. And this is more of a virtual view. And let me expand this a bit. This is a virtual view of the files that compose your application, where we're not going to see every single file. For instance, you don't see either the bin or obj directories over here. They are not going to be seen here, because this view is more like to help you manage the dependencies across different projects, and also to help you create files for C# files for your solution. We're going to see how this Solution Explorer is going to be very handy in several situations. But for the most part, we're going to be working mostly with the File Explorer, which is going to be good enough for most tasks. Now, let's do a quick overview of all of the files that got created. We're not going to go deep into all of these files, but at least I want you to get an idea of what each of these files is for in your application. So let's go ahead and just close our welcome screen over here. And let's go ahead and open up our program.cs file here. So this right now is the only C# file that is available in your project. And these few lines of code that you can see here are the very first lines that execute when you run your application. So this is the code that pretty much bootstraps your application. And the whole purpose of these lines here is to really create an instance of this web application object here. So app here is really of type web application. And web application is what we know as the host of your application. Now, what is the purpose of this host? Well, the purpose is really to represent or to introduce an HTTP server implementation for your app, so that it can start listening for HTTP requests. It also stands up a bunch of middleware components, login services, dependency injection services, configuration services, a bunch of services that we're going to be talking about across this tutorial, and that you can configure over here. If we expand this, between these two lines, you could go ahead and always just type builder dot, and this is going to give you the chance to go ahead and configure a series of services depending on your needs, right? By default, as you can see, there's nothing in there. But we're going to be working a lot with this builder object to introduce services as we go across this tutorial. Now, when you actually go ahead and invoke build over here, this is going to build the instance of that web application, and that's going to configure or set up a few things. Like, for instance, it's going to go ahead and set up Kestrel as your in-process web server that comes in with ASP.NET Core. It also loads configurations from a few other files that we're going to be talking about, and also configurations for environment variables, command line arguments, and many other configuration sources. It is also going to allow us to send the login output into the console that we can see in the terminal. All right. And so after we have this instance of apt ready, then we go into what we know as the configuration of the request pipeline. So all of these lines, and let me just set here, between line 3 and 7 here is what we know as the configuration of our request pipeline. So this sets up what is going to happen when requests come in, how should we handle those requests, right? And right now, as you can see, really all we have here is this one line over here, which all it does is says, well, if a request comes for the get verb, this get verb into the root of my application, I'm going to reply with this lambda expression that you can see here. This is known as a handler. It just replies with a hello world. That's all it is doing right now. Very, very simple. But you can use this app object also to do a bunch of things. Like if you just type app here, you're going to see that there are a bunch of things that you can do to modify what happens when these requests come in, right? That's done as a request pipeline. And again, we're going to see how to take advantage of this app object across this tutorial. Okay, so yeah, that's it for the program.cs file for now. Now let's take a quick look at the other files that are available here. Another very important file is known as the project file, this gamestore.api.cs program. What is this file for? Now this is known as a project file, and this one defines a few things, like for instance, what type of project that you have here. So as you can see at the very top here, we're using the SDK Microsoft.NET.SDK.web. That means that this is a web project that we want by default to import a bunch of libraries and dependencies that are specific for web projects. There are many other types of projects that you can create with .NET, but in this case, we're focused only on web projects. And then if we go down here, we're going to see that we have our target framework. So in this case, it says .NET 8.0. That means that we have access to all of the APIs that are available in version 8 of the .NET SDK, right? So if you have a lower version, it means that you have access to likely less APIs. If you have a higher version, you have access to newer APIs, right? By the time that I'm recording this, the version of the SDK that I'm using is version 8, so that's why it defaults to .NET 8.0, right? And then there are also configurations for other C# features that I'm not going to dive into right now. But another thing that you're going to notice in this CS proc as we go through the tutorial is that this is where we're going to be declaring all of the dependencies or other libraries that we may want to use to take advantage of their functionalities without having to write our own code. We're going to see that as we go across the tutorial. Now, let's go back into our Explorer here. And now let's take a look at our appsettings.json. Now, we have appsettings.json and appsettings.development.json. So these are the files that are commonly used for configurations, right? So this is where you would put everything that should not be hard-coded into your code base, but more represents a set of configurations that could change across environments, right? So for instance, right now, we already have some configurations for logging, right? But we also have this appsettings.development.json that we could use if we wanted to, so that it only works in the development environment, so in your box. But these settings will not be used as you move into production. For production, you could either use appsettings.json or you could introduce other set of configurations from other sources. And we're going to be talking about those configurations later in the tutorial, right? Now, another file that we have here is under properties. There's this launch settings.json file. Let me collapse this for a moment. Now, the main purpose of this launch settings.json is to provide you what we know as profiles, right? And we have two profiles here. We have an HTTP profile, and down here we have an HTTPS profile. Now, these profiles provide you with some configurations only for development. So this is just for local development that kind of impact the way that your application is going to run in your box. For instance, this setting here states that the browser should open anytime you start debugging your application. And this one here is the URL that's going to be assigned for your application when you started. This URL, by the way, this port over here is automatically generated, so you will likely get a different one when you create your application. There's also something like environment variables, as you can see here. This environment variable, ASP.NET Core environment, is a well-known environment variable that tells the .NET runtime or the ASP.NET Core runtime that we are working in a development environment, not in a production environment, right? And so nothing in this file is going to be available in production. So when you go into production, all of this goes away and you get actually into a production context. So all of this is really meant for local development. Now, just like you have HTTP, If you wanted to run with HTTPS, you can take advantage of the HTTPS profile, which is going to provide another URL over here. As you can see, this will be the URL for HTTPS access. All right. Now, what else we have here? Well, we have our bin and obj directories, which is really where our temporary files, in obj is where we're going to have our intermediate files as we go into the compilation process. And later in bin is where we're going to have the final DLLs or assemblies for our application. Okay, so that's it really for the files that we have in the application. Let me collapse this, and close that. Now, how do we actually build this project? How do we end up, going from the code into the binaries? So that's what we know as the build process, and it's actually very easy to do. So let me collapse this. There are a few ways to build your project in VS Code. Now, one way, and I think the easiest way to do it is by using the Solution Explorer. So if you go to Solution Explorer down here, I'm going to collapse that one for a moment. All you have to do is just right-click in your project over here, GameStore.api, right-click, click on Build, and that's going to go ahead and kick off the build process based on the solution that you have currently on, right? And as you can see right here, we have our DLL produced, as it says right here, GameStore.api.dll. Where is it actually living? Well, if we go once again back into our file explorer into bin, let me expand this a bit. There's bin debug because we are in the debug configuration, and net80 because that is the framework that we're targeting. We're going to see that we have our GameStore.api.dll. So that represents the actual assembly of the compiled version of our application. Okay. And so, yeah, and that's one way to do it. But like everything else, I recommend that you also know how to do this from the command line, CLI. And so to do that, what I'm going to do is just click on this plus sign over here to open a brand new terminal, plus. And then perhaps I'm going to delete the other one. I'm going to click on this delete over there. And then to build your project, all you have to do really is just type .NET, so .NET CLI, and then build. That's going to go ahead and build whatever solution or project you are in. So since right now I am at the root at GameStore, it builds the solution GameStore SLN that includes the project that I'm working on right now. Okay, so that produces the DLL. And one last way to do it, if you wanted to do, is to by using Control-Shift-V, which is going to tie into the native VS Code integration into what we know as build tasks, right? So as you can see, it already knows that our build task is .NET Build, so you can just click there, and that's going to go ahead and kick off the build process, right? So many ways to do it, so you can choose whatever works best for you. Now, how do we actually go ahead and run the application? Right now we know how to build it, but how do we run it? It's actually very straightforward. Easiest way to do it is by just hitting the F5 key. So if you just hit F5, that's going to go ahead and open up this dialog that you can see here, asking you to choose what is going to be the debugger for your application, right? Because this is going to actually go into a debug session, not just run the application, but into a debug session. Now, of course, we're working with a C# application, right? So you want to pick C# here, right? And now you have to pick what is going to be your configuration that you want to work with. Like I mentioned before, in launchSettings.json, we have two profiles, one for HTTP and one for HTTPS. And there's also the concept of the default configuration, which is going to be really the HTTP configuration. So let's just go ahead and click on the default configuration. And now VS Code is going to go ahead and build the project, and then it's going to kick off the debugger with a debugger attached into the application. And as you can see, it even went ahead and opened my browser. And let me expand this for a moment. It opened my browser, and it went into executing a GET request into the API, right? And as you remember, if you go back into VS Code, what happens if somebody executes a GET request? If we go to program.cs and let me for a moment, we are expected to return a hello world. And because of that, that's what we're seeing in the browser right now. You're returning hello world. Notice that we are right now at the host and port that was specified in launchSettings.json, right? So localhost 5274 would match what we have set in properties launchSettings.json. It's going to be up here, localhost 5274, right? So that's what got launched over there. But then, like I mentioned, this is not just running the application, it's actually inside a debug session. And how can we tell that we are actually in a debug session, though? Let me show you that. So let me go back into VS Code, and I'm going to temporarily just stop the debugging session for a moment. So you can see we have this stop button over there where we can use to just stop the debugging session. So I click on that, I'll close this, and I'm going to place a breakpoint in my program CS over here, perhaps over there, which is where we are configuring our GET request and later executing our hello world land over there. So now if I hit F5 once again, VS Code is going to build the project and attaches a debugger into the application. And as you can see, this time we actually stop over here in the breakpoint, line 5. And from here, we can go ahead if we wanted to and start evaluating the different objects that are live now in the application, right? So we could go ahead and hover over app, for instance, and that's going to give us the values of the different objects that are available right now from ASP.NET Core, right? The web application object. And not just that, we could see variables. I mean, the builder, the app on the left side, we could add watches. We could check out the call stack also if we wanted to. But indeed, we are in a debugging session. And to continue, all you have to do is just click over there, over here, click on that play button, and that's going to continue the execution. Now, this opens up the browser once again, browsing into the root of the API, but we have hit the breakpoint once again, and that's because now we are inside the Lambda that executes when the actual request lands, right? The first time it executed because we were booting or starting up the application, and now we actually hit the get endpoint, and we are invoking this hello world Lambda. Okay, so just click on play once again, and back in the browser, you're going to see that it presents the hello world once again. Okay, so that's how you can, easily start debugging in your application. Now, what if you don't want to go ahead and debug all the time, that would be my case. Like, you don't need to be debugging all the time because it can be a bit time consuming if you keep doing that over and over again. So what you can do, and let me just back here, stop my debugging session. What you can do is either go back into Explorer, right? You can go into Solution Explorer and you can right click in your project over here. You can go ahead and say debug, and then you could do start without debugging, right? Start without debugging. So this is going to start your application without any debugging support. Notice that it was way faster. Still opens the browser, but it was way faster, right? Or another thing that you can do, right? Let me stop this once again, stop that, which is going to be also my favorite here, is going to be by using the terminal directly. So if we collapse this for a moment, and let me expand my terminal, going to call these 3 dots and into terminal over here. I'll kill this terminal back into this simpler one. Okay, and I'm going to switch into gamestore.api, which is the location of the actual API that we have created. And I'll just type .NET run. By doing that, once again, I'm running the application, right? But there's no debugger attached. And we're going to see in nicer colors the logs that are going to pop up out of the application. And we can clearly see where it is that we are hosting the application, localhost 5274. So by being here, I can, once again, go back to the browser, just refresh this, and again, it's going to send back hello world, right? And so now that we understand how to create our project and how to build and run it, let's now switch into slides to understand much better what exactly is a REST API. In this section, you will learn what a REST API is and how it relates to modern client applications. To understand what a REST API is, start by thinking about all these apps you have in your phone, like your weather app, LinkedIn, or Spotify. These apps use a ton of data, like the latest weather information, the latest post in your LinkedIn feed, or the hundreds of songs in your favorite playlists. However, that data can't live in your phone, which is what we know as a client, because it will be way too much data to store in your device, and you want fresh data all the time anyways. So the data has to come from somewhere, and that somewhere is going to be some sort of server computer that usually lives somewhere in the internet cloud. But how can these apps talk to that server in the cloud to retrieve the data? Well, by using an API. API stands for Application Programming Interface, and is how a service defines the functions it provides to clients. So, for instance, going back to the Spotify example, the Spotify Cloud Service could define an API with 2 functions. A get recent songs function that receives the username as a parameter and that returns the 10 most recent songs for a specified user. And there could also be a play song function that receives the song name as a parameter and that returns the stream for that song so that a client can play it. Like this, there could be dozens or hundreds of other functions offered by the service that clients can use to interact with it. So an API helps clients communicate what they want to the service so it can understand and fulfill the request. REST stands for Representational State Transfer. and it defines a set of guiding principles that impose conditions on how an API should work. We won't dive into each of these principles in this tutorial, but the important thing to know is that thanks to them, you can build APIs that are scalable, flexible, and independent of the technology being used on the client and the server. So, going back to the original question, a REST or RESTful API is one that conforms to the REST architectural style. Now, the main reason why we want to stand up a REST API is so that our clients can interact with the data that it manages. But how do they actually reach that data? Well, for this, it's good to first understand the concept of a resource in a REST API. In a REST API, a resource is any object, document, or thing that the API can receive from or send to clients. For instance, in our game store application, the main resource is going to be our games. That's what clients want to query and modify. But in other applications, like the Spotify example, one of the resources could be the songs. And in the LinkedIn example, one resource could be the users, and another one, the LinkedIn posts. These resources will be hosted on some domain, which could be a public domain, an intranet location, or it could be just your dev box. And they can be accessed either via the HTTP protocol or the HTTPS protocol, which is a must in public environment. So when you combine all these, you get what we know as a Uniform Resource Identifier, or URI. And that is what your clients will use to identify and reach the resources of a REST API. There could be more parts to this URI, but these are the essential elements. Now, how do you actually interact with the REST API? Well, just like with traditional web pages, when clients want to request something from the servers, they will send an HTTP request using the resource URI to the server, and then the server will send back a response. However, in REST APIs, these requests and responses will look a bit different depending on the specific HTTP method used to call it. The most common methods are POST, which creates new resources, GET, which retrieves the representation or state of the resource, PUT, which updates an existing resource, and DELETE, which deletes a resource. So these methods allow you to create, read, update, and delete resources, and therefore they are also commonly known as CRUD operations. There are other methods too, but for the purposes of this tutorial, we'll focus on these 4 ones. Let's take a look at each of these methods in the context of our game store example to understand better how they work. To request all games, a client will send a GET request to the game's endpoint, and the server will respond with something like this. The first part of this response is the status, which is 200 OK in this case. This means that the operation was a success. There are many other HTTP status codes that a REST API will send back depending on the result of the operation, many of them for failure scenarios. The next part is the body, which contains the list of games in this case. Notice that this body is not HTML, but instead the format of the response is known as JSON, which stands for JavaScript Object Notation. This is the de facto format for sending and receiving data in REST APIs because of how easy it is to read and write, and is supported by all major programming languages. If instead of getting all games, you wanted to get a specific game, you would again send us a GET request, but this time you would append the resource identifier at the end, number 1 in this case. The server will respond with the state of the game with that identifier, assuming it's able to find the game. To create a game, the client can send POST requests, once again using the game's resource URI. But this time it needs to specify the desired resource state in the body of the request, which in this example only includes the name of the game, but could include many other properties, of course. The server will usually reply with a 201 created status code, and if the resource identifier was not specified as part of the request body, the response will usually include it. To update an existing game, the client sends a put request with the same resource URI as the one to get a game. But this time it includes the resource state, just like in the post scenario. The server will completely replace the state of the game associated with the specified identifier with a new state, and will typically respond only with a 204 no content status code. Finally, to delete an existing game, the client sends a delete request to the URI that identifies the game to delete, and after deleting the resource, the server will usually respond with a 204 no content status code. So, in summary, your complete games REST API would look like this, and should offer all the support that your clients expect from a modern backend. Let's now jump back into the code to see how to implement this REST API in ASP.NET Core. Before we start implementing our .NET REST API, we need to find a better way to interact with it. And that is because the browser is not really designed for this kind of work, and you can only do so much from the browser. So instead of using the browser, what we're going to do is find another way by using directly Visual Studio Code to talk to the API. And let me show you how that works. So back in VS Code in our File Explorer, let's go ahead and just right-click on our project folder, gamestore.api in this case. Let's do New File, and let's name this file games.http. The name of the file doesn't really matter. What matters is the extension. And this file is recognized by the extension that we installed before, this one called REST Client. That extension allows us to write statements directly in this file that very quickly allow us to interact with the API. So for instance, remember that we have our hello world declared over here, right? So far, this is all we have. How do we interact with that? Well, all you have to do here really is just say get, because it's going to be a get request. And then we want to specify the host and port of our running API. So to figure that out, remember that you can always go into launch series.json, look at your HTTP profile, this profile over here, HTTP, and here is your application URL. So I'm going to copy this, close that. I'll just paste it over there. And now we are pretty much ready to talk to the API. So how that works? So let me collapse this. Let me open my terminal. I'll do Control J to open my terminal here. I'll switch into gamestore.api, and I'll just do .NET Run. Right? Remember that there are many ways to run your application. This is just the way that I like to do so. So now what I can do, and I'm going to collapse this for a bit. What I can do now is just right-click over here where I have declared this line 1. I'll just right-click, and I'll use this option here that says Send Request. Send Request. Click on that one. And on the right side, I'm going to collapse the terminal. You can see that we get a response right away, including the hello world that we were already expecting, that we were seeing before in the browser. Now we're seeing it here. And not only that, we can also see the status code of the response and a few other details about this response. And so you can also go here. I mean, there is this send request link over there that you can always go ahead and click. It's going to have the same effect. I have found that at the time that I'm recording this link is not super reliable, so sometimes it may not work. So that's why I prefer to do it the other way. But another way to do it is also to do Control-Alt-R, in Windows at least. Control-Alt-R is going to go ahead and execute the request for you. So as you can see, this is a much better way to interact with the API. But one problem that we still have is that anytime we start a debugging session, the browser is still going to open, right? So if I just close this and let me open up my terminal over here, I'm going to do Control-C to stop the process. Process stopped. Now I'm going to do F5 to start a debugging session. And what's going to happen is that, of course, it builds and the breakpoint is being hit. I'm going to remove this breakpoint. And then the browser opens again, right? So this is not something that I like because we're not going to be doing anything with the browser. And even in a debugging session, I'd like to just stay within VS Code. So how to prevent the browser from opening? So let's go back to VS Code and let's stop this debugging session. What we can do is just go and I'll do Control-Shift-E to open my Explorer view. And then I'll go into my launch settings.json file, right? And so in this file, all you have to do is just switch launch browser from true to false. And I'll do that both for my HTTP and my HTTPS profiles, right? We're not going to be using really HTTPS, but just in case, let's switch it in both sides. All right. And just by doing that, if I hit F5 once again, I'll hit F5, you're going to notice that we just remain within VS Code. And if I want to, I can go and just close this, and I can go ahead and right-click in my games.http and send a request, right? Which now it is sending the request, but we are in the context of a debugging session. which is going to be super handy in many occasions. All right. So yeah, so let's now stop this. Let's close this, and this. And let's go back to the Explorer view, Ctrl-Shift. So now it is time to start the implementation of our API. But there's one thing that we're missing so far, and that is a way to represent the resources that we're going to be managing in this API, right? Like we said, we're going to be managing games, video games, right? It's a catalog of video games that we don't have a way to represent those. If you remember, if you go back into program CS, I'm going to collapse these properties also. In the program CS, we have already defined this one. Well, by default, we get this map get that all it's doing is just returning this hello world, right? Which is a simple string. But in our case, we may want to have multiple properties that are associated to our games that we're going to manage. So things like an ID, a name, and a few other things, right? So what we're really missing here is what is commonly known as a data transfer object. Now, data transfer object, or DTO, is an object that carries data between processes or applications. It encapsulates data in a simple and standardized format that can be easily transmitted across different layers of an application or across different applications. So let's see how can we go ahead and define a DTO to represent our games. So let's go ahead and just close this file. And for this, we're going to be using actually the Solution Explorer down here, Solution Explorer. Let's open up that. And we're going to be using this anytime we want to create either folders or files for our project, because it's just easier to do it here than in the standard File Explorer. So right-click on the GameStore.api. Let's add a brand new folder. And we're going to name this folder DTOs. Now, keep in mind that other folks like to name this folder contracts as opposed to DTOs, which is totally fine because a DTO can be considered like a contract between the client and the server because it represents the shared agreement between client and server about how the data will be transferred and used. So if you want, go ahead and name these contracts. That will be totally fine. It's just really the same thing. Now, in this directory, let's right-click on DTOs. And let's create a brand new file. It's going to be, in this case, it's going to be a record, not a class, but a record, right? And let's name it game DTO. Okay. Now, why are we using record types here as opposed to a standard class? Well, the thing is that by default, records are immutable, meaning that once their properties are set, we usually, at the time when we create these records, they cannot be changed, right? And this immutability is a perfect fit for DTOs because they typically carry data from one point to another without the need for modification. And on top of that, records reduce the boilerplate code that is typically associated with class definitions intended for data holding, like DTOs. As you're going to see, you can define these records with just a single line, including all the properties, which simplifies the code base and makes it much more readable. And it has, record types have many other benefits, but these are the main ones that I see that are very useful for DTOs, right? So let's go ahead and let me collapse this. So how do we define this DTO? First thing that we should do here is to actually match the namespace with the file structure. So let me open up my Explorer again. Remember that this is on our DTOs directory. And because of that, I like to always follow the structure of my file system. I like to follow it also in the namespace. So for that, you can either type here just .dto, or you can use this label over here. You can click on that. And you can select the option that says change namespace to GameStore.api.dtos, right? So that's going to make it so that it matches, right? Let's collapse this. And now let's define the properties for the DTO. Now, DTO is actually very easy to define. We don't actually need these curly braces. All we want to do is just open parentheses here. And here we can start declaring our properties. The first one is going to be our ID. That's going to be an int ID. And then the next property is going to be a name. Let's follow that with a genre. So genre is like, is it sports, racing, role-playing, whatever kind of game we're dealing with. We also have a price. And then at this point, by the way, let me just send this to the next line so we can see better what we're working with here. Okay, we have the price. And lastly, we're going to be specifying a release date. For that one, we're going to do date only, release date. And we're doing date only because we don't really care about the time. All we care is about the date portion of the date when the game was released, right? Awesome. So now we have our DTO ready. And now we're ready to go ahead and start taking advantage of it. So for that, let's go ahead and open our Explorer view once again, Ctrl-Shift-E, and let's go into Program CS. Let's collapse this. Now, as we start writing the next few lines, just keep in mind that our API is going to be evolving across this tutorial, right? So you may see that the initial code that we write for this is going to be a little bit dirty and odd, but it's meant to start like that just so that we can solidify the initial concepts of REST APIs first, and then we're going to see how to refactor and get into a much better implementation. And in that sense, what we're going to do here is to define a very simple list of games in memory using our DTO class. And we're going to see how to implement the different HTTP methods along or around that in-memory list. Later in the tutorial, we'll see how to transition from that in-memory list into an actual database. So what we're going to do here is perhaps just after the definition of our web application object over there, we're going to declare here a simple list of our game DTO, right? And notice that by selecting game DTO, VS Code automatically added a using statement over here, GameStore.api.dtos, right? So that it just did it by itself. And that's what gives us access to the game DTO type. Now, the name of this is going to be just games. And we're going to define that list right here. Now, I have already prepared a small list of games just for us. So just so that you don't see me typing so much. So let me just go ahead and grab that list from my other window over here. So as you can see, I have now 3 games, right? So here is just my favorite games, right? So ID 1 is going to be Street Fighter 2. The genre is fighting. Now we have the price here, and we have an M here because we want to specify clearly that this has to be a decimal, right? Otherwise, we're going to get kind of a warning here because the compiler will not know if it's decimal or double or what is this, right? So it's going to be decimal in this case. And then we have a date only. In this case, here's the date for that first game. And then scrolling down, we have ID2, Final Fantasy 14, role-playing. Here's the price, here's the date. And lastly, we have another of my favorite games, FIFA 23 with ID3, sports, here's the price, and finally, the release date. All right. Now, how do we go ahead and actually implement an API that can return these games over here, right? And so for that, we can actually follow the pattern that we have down here, right? So what you do is you say, okay, you use the web application object, and you say, okay, so what kind of a verb I'm going to implement? In this case, we want to do a get, right? A get operation. So it's going to be map get. And then you want to specify what is going to be the path under which this endpoint is going to be located, right? In this case, following proper REST practices, we should name this as games because the API is going to be all about managing games. Now, notice that this is not going to be named just game, right? It is game in plural because that is the way to address the group of resources that you're going to be dealing, all right? It's very important to keep those conventions like that. Now, after you define that path, what you must specify is the handler, right? So how are you going to be handling a request that comes into that path? So in this case, really all we have to do is just return that list that we have in memory there. So we're going to do just this, games. So this lambda expression just says that we're going to be returning whatever is in the games list over there. And really that's all you have to do. And this is really why this type of API is known as a minimal API because it is very quick, very easy to declare, as you can see over here. Now, let's see how that works in practice. So I'm going to go ahead and just run my API once again. And I'm going to click on these 3 dots going to terminal. And I'm going to delete this last one. There. So I'll just do .NET run. All right, .NET run. And then what we want to do is just go back into games.http. And what we can do is just modify this one request that we have here to actually target our API. Remember that it is under the games path. So I'm going to just copy games over here, /games. And that's pretty much it. So I'll just right click, I'll do send request. And as you can see on the right side, we get a 200 OK response. So it was a success. And down here, we have the actual games. So notice that we have here Street Fighter 2, we have Final Fantasy 14, FIFA 23, it's all there. And then, like I mentioned before, this is expressed in JSON, right? So ASP.NET Core took care of transforming our C# objects, serializing them into JSON notation, as you can see right there. All right. So yeah, so that's our get endpoint. And then now let's go ahead and close this. And let's go back to program CS and let me also Ctrl-J to open my terminal, Ctrl-C to stop it. One thing that we may want to do at this point is just get rid of this hello world because we don't really need it anymore. So I'm going to remove it. Now, just so that we can keep track of what exactly each of these endpoints is expected to do, I'm going to add a little bit of a comment here. So this would go for a get games, right? So whenever somebody goes into get games, this is the endpoint that's going to respond. Okay, just as a little bit of documentation. Now, what we want to do now is to perhaps create the request that can be used to retrieve not all the games, but just one game. How would you do that? Get a game by ID. So it's a very similar idea, actually. So what I'm going to do is just say, perhaps let's do the documentation first. It's going to be something like games slash one, for instance. How do you represent that? So app, map get, okay? And so again, we start with games, but this time we need to provide one more thing, which is going to be the identifier in this case. So for that, in this, what is known as the pattern, we can specify with these curly braces, we can introduce a kind of the variable that we're going to be using to receive that ID, right? So that goes in the raw template. And then in the next parameter for the handler, what we're going to do is now not receive just an empty argument list, but we can actually receive that ID that we specified there with the exact same name, int ID, right? And then this leads us into the actual execution that we want to perform here. So what will we want to do in this case? Well, just find the game that has that ID. So for that, we can just use the find method of list. So games.find, and then we will do game where game.id equals the ID. And just like that, we should be ready to go ahead and query for one specific game. So once again, let's run our API.NET Run in the terminal. Close this, go back to games.http. And what we want to do now is to just add another request here. Now, to separate your request in this file, what you want to do is just introduce these 3 pound signs, and then you can add your request. And I'm going to copy the first one down here. Notice that because we have these 3 pound signs, we also get the same request link over there, which means that it is recognizing it. So without these ones, it will not do that, right? It just goes away. Make sure that you add that. And now that I'm here, I'm going to just append slash, and then we want one of the games. So let's do number 1, and then let's right click. Let's do send request. And on the right side, you're going to see that we are indeed getting that game number 1, right? So you can see it's game number 1, right? So yeah, very simple and very similar to what we did before, right? So let's close this and let me Ctrl+C stop my server. Back to Broncies. Before we move forward, notice how we keep using the proper REST notation as we define our endpoints, right? So for instance, in this case, when we did games by ID, we prefixed everything with the name of the resource or the plural of the name of the resource, in this case, games. And it has to be like that, right? So you cannot say something like get games, right? That will not be correct. It has to be games. Or you cannot either say something like games by ID and then something like this, right? That will make no sense. So to follow proper REST notation, you always start with the grouping or the term that represents the group of resources. And then you follow, when you want to specify something or find something by ID, you follow with the ID or the identifier of that resource, right? So this is the right way to define resources in REST. If you're not doing it this way, you're not doing REST, right? So now let's move forward to the creation of brand new resources. How do we do that? Well, we have to create a post endpoint for this. But before we can do that, we need to define how is that or what is going to be the representation of those resources we're going to be receiving into that endpoint. It is similar to the one that we're using today for, the game DTO for returning resources, but it's not exactly the same one, right? And let me show you how this should actually look like. So let's go back into our Explorer over here. And we are in Solution Explorer. And what we're going to do is right-click on DTOs and create a brand new file. And again, it's going to be a record, not a class, a record. And this one is going to be named Create Game DTO. All right. And then once again, let's go ahead and fix the namespace. And here's one tip for you. Anytime you see a label over there, instead of clicking on it, you can just do Control dot. Control dot is that's going to open up this context menu, and then you can pick whatever makes sense. In this case, change namespace to GameStore.api.dtos, and that will fix that. Now, to define this DTO here, we could grab a bunch of the properties that we have in our other, in our game DTO over there. Let me go ahead over here. I'm going to paste those, but there is just one difference. I'm going to paste those over here. And the difference is that when we create a game, we actually don't have any ID, right? The ID is going to be provided by the server, by the API itself. So we are not going to require clients to send us an ID. Because of that, we're going to be removing this from there. So we stick with the name, the genre, the price, and the release date. Now, this DTO is going to be changing later on in this tutorial. This is just an initial version. But for now, notice how the contracts that we're going to be using either for returning data or for posting data into the API may be different, right? So that's where we want to be very specific on what we're going to be requiring from the client for each case. All right. So now that we have our create game DTO, let's go back into program.cs and we can go ahead and define our brand new endpoint. So the endpoint is going to be for the post verb when somebody posts something into the game's endpoint. And just as before, what we can do is just say app, that in this case is going to be map post. Okay. And of course, it is when somebody posts something into games. And in this case, in our Lambda, what we're expecting to do is to actually receive an object of the type of our DTO, the brand new create game DTO. And let's just name this one as new game. All right. Now, what are we going to do in this case? So let's go ahead and actually expand. Let's have a body for this one so we can be a bit more verbose in this case. What we want to do is just to kind of convert this create game DTO into a normal game DTO just to add it into our in-memory list for. So for that, let's just do game DTO. Game is going to be a new, okay? And let me open and close here. So the first parameter here, of course, is going to be the ID. So what is going to be the ID of this game? Now, how are we going to come up with an ID? Well, for now, what we're going to do is just add +1 to whatever count of games we have so far. So in this case, we're going to say games.count, and we're going to say just +1. All right, that's going to be our ID. Then we go for the name. So that's going to be new game.name. And then we go for the genre. So new game.genre. Then new game price. And lastly, new game release date. Right? So that's going to go ahead and complete the definition of our brand new game. And then, and let me scroll down a bit. What we can do is just say games.add our game. Right? So the game is part of our list. And lastly, what we want to do is return something back into the client to tell the client what was the result of the operation. Did it succeed? Did it fail? What happened? And we can provide even more details. And the standard in this case is to return a 201 created response. How do we do that? So all you have to do is just say return, and you can use the results class, right? So this is a built-in class in ASP.NET Core, results, and then this contains multiple pre-built responses that you can use so you don't have to manually specify the status of the response. So in this case, what we're going to say is created at route, okay? And then we use this because with this, we can provide a location header back into the client so the client knows exactly where to find the resource that just got created. So how do we do that? So the first parameter here is going to be the name of the route where the client can find that resource. Now, we have not actually defined the name of that route so far. But to do that, what we're going to do is just go back a little bit into our map get by ID route over there. And just before closing this, we're going to just do here dot with name, right? And this is a method that you can use to specify to give a name to this endpoint that we have defined there because it doesn't have a name so far. So what name we're going to give it? So let's just name it get game. Okay, so get game. And then now we can use this exact same name down here in our return created at route get name, get game. And ASP.NET Core is going to take care of figuring out what is the route to that endpoint, right? And to use it to build the location header to return back to the client. Okay, the next parameter that I want to specify here, what is going to be the value that needs to be provided to the get game route. Remember that get game receives an ID right here. It receives an ID. And so we need to provide that ID back into the response that we're going to provide here. For that, we're going to be using, the standard is just to use an anonymous type. So we're going to use say new, and in this new, we're going to declare that it has an ID, and that ID is going to be game.id, the one that we auto-generate. Last parameter here is going to be the actual payload that we're returning back into the client if we want to return a payload. So for that, we're going to be using game. All right. And so now, just to keep things a little bit cleaner, what I like to do is to not have this name repeated twice, right, over there and down here. And instead of that, let's define a constant that we can use to refer to this value. So let me just copy this, and let's go all the way up here. Okay, before the declaration for list, we're going to define a const string. Let's name this one get game endpoint name, and that is going to be get game. Okay, so now we can just copy this constant, and down here we can replace that with name right here. This is the get game endpoint name, and down here we can use it all, right? So that way we avoid having these hard-coded values. All right, so with that in place, we are ready to go ahead and test our brand new post endpoint. So open the terminal, and I'm going to just do .NET run. All right, so it is running. So let's collapse terminal. Let's go back to games.http. And of course, what we have to do is define a new request here. So £pound over there. And then we're going to be doing a post request. It's going to be same endpoint, right? With no ID, right? It's just the endpoint, games endpoint. And then one thing you have to specify here is the content type, right? So that we can tell our API what kind of content we are sending over there. So in this case, it's going to be content type. And the content type in this case is going to be application JSON, right? And then in this case, we'll have to just leave one empty line over there. You need to leave this one empty line. And then in the next line, this line 10 in this case, we're going to define the payload of our game we're going to be creating. Remember that the payload has to include a name, genre, price, and release date as per our create game DTO. So back in the HTTP, here's the HTTP. I'm going to define that, but just to not write too much, I'm going to actually copy it from my other screen over here. Here's our first game. So this is going to be, as you can see, it has a name, genre, a price, and a release, right, in JSON format. So with that in place, and since our server is running, we should be able to go ahead and execute this. So I'm going to just right click here, and I'll say send request. And as you can see on the right side, we are getting the expected 201 created response over there. Okay. And then down here, we can see the payload that represents the game that was created, right? Notice that it has the ID 4. There's a fourth game in our list. And it not just has the payload down here, but it also provides us with the location header, right? Notice here, here's the location header that ASP.NET Core created for us because we provided the right values for the created at route method that we use, right? And since we have this, the client knows that now the client can just use this. And I'm going to copy this. I'll just copy that, close this, and the client can go and say, for instance, let's say over here, we can replace that. And now we can right click and send request. And now the client was able to query for that brand new game right there, game number 4. And of course, if we execute the first request, we should be able to see that we have total of 4 games over here. 1, 2, 3, and 4. Here's the 4 games. All right. And yeah, that's it for the implementation of our get endpoint. Let me just stop my server here and let's go back to program CS. So now we're able to query for games and create brand new games. So how about updating existing games, right? So for that, of course, we're going to be needing a put endpoint. But before that, just as before, we need a brand new DTO to represent the payload that the client should send when they want to update a resource. So let's go back into our Ctrl-Shift-E, our Explorer here. This is Solution Explorer. Right-click on DTOs, add new file, record. And then this is going to be named update game DTO. Now, we could certainly just use create game DTO for the same purpose, but really the convention is to always specify a brand new contract or DTO for every single new operation, because eventually things could change, right? It could be that you may need to do something different for updates that is not needed for creates. And so I don't want to be messing with those contracts. So just keeping them separate, one for each operation, right? So let's go ahead and collapse this. And I'm actually going to go ahead and grab what we have in create right now. So I'm going to copy this into update because like I said, right now it's the same thing. Could change later, but for now it's just that. And with that DTO in place, let's go back into program.cs, program.cs over here. And let's define our put endpoint. So I'm going to move down here. Let's go and do this so we can see better. And let's define our app. And by the way, let's define that this is going to be for a put into games, right? And so app that map put, in this case, map put. And then once again, this is going to go into games. And then just like in get by ID, we need to specify what is going to be the ID of the resource that needs to get replaced, right? Put in here means replace resource with whatever I'm going to be sending, okay? And then we are going to specify two parameters in this case. It's going to be inside our arguments lambda, the ID. We need that ID that we just specified in the template. And then, of course, the update game DTO, updated. All right. Now, let me just check one thing. Yeah, we forgot to fix the namespace over here. We should always have the correct namespace. So let me do control dot here to change namespace to gamestore.api.dtos. All right. And then what do we do about the body of this put? So let's open up our body for the Lambda right there. And what we're going to do here is just find the game in the list, the existing game in the list for the ID provided. And we're going to then replace that game in that list with a brand new representation, right? So let's first find the index of the game. So we're going to say index. It's going to be games.findIndex. And then for the game where game.id is it that we got as a parameter. So that gives us the index of the game. And what we can do now is just go into our list, games, and then at the index of the found game, we're going to create a brand new game DTO, right? So let's open and close parentheses. And then, of course, here we're going to be just filling the slots, right? So it's going to be the ID, and then we have updated game.name, updated game.genre, updated game.price, and updated game.release date. All right. So with that, we have replaced the game in the list. And last thing is to return something back to the client. Now, the convention for an update is to just return no content, right? So return results that no content. And that will be pretty much it for our put operation. Now, you may notice that we are not covering all of the cases, right, in this API so far. Like, what happens if I cannot find the game, right? So we're going to go back into those later in the tutorial. For now, I just want to get a complete set of endpoints that we can work with. And then we're going to go back and start refining these endpoints with whatever pieces we are missing, okay? So for now, just happy path. So now we have our endpoint defined. Let's go back into our games.http and let's see how we can query, send a request for this put endpoint. So just like before, we're going to open a brand new section. This is going to be a put, right? It's a put request. Now let me just copy this. The endpoint goes into /games. But of course, like I mentioned, we want to specify, in this case, we need to specify the ID of the resource that we need to replace. So in this case, it's going to be /1, let's say to replace the very first game that we have in the list. And then, well, what is that game? So to know that, let me actually start our server. So let's go ahead and do .NET run. So we can start a server. Let's query for all the games, right? So in this one here, right click, send request. Right. So what is the first game? Is this one here, Street Fighter 2. What I'm going to do is just copy the body of this first game. Just going to copy it. And then down here, I'm going to use that for our put body. Now let's not forget to use content type, application JSON over here. And then let's paste that down here. It looks like I didn't copy it properly. I'm going to just grab it from my other screen. There. Here we have. And what I did here really is just modify the title, right? Notice that the initial title, as we can see right here, was Street Fighter 2, right? Price is $19.99. So I'm going to make a small change so that the game is now going to be named Street Fighter 2 Turbo. And then the price is going to be just way cheaper. It's going to be just $9.99, right? Those are the two changes that we're going to introduce into this game. But just keep in mind that put is going to replace the object, right? That's the purpose of put, replace the object completely. So with that in place, let's go ahead and right click and hit send request. And as you can see, as expected, we get the 204 no content. That's the expectation. That's good. And then if we want to verify that things the game actually changed, all we have to do is just go and query for game with ID 1 in the get. So right click, send request. And on the right side, we should be able to see that, yeah, indeed, Now it is Street Fighter 2 Turbo, and then we have the brand new price over there, right? So the put operation is working as expected, right? So let's close this and stop our server. Right, back to Program CS. Now, before we move on into the last operation, the delete operation, one thing that you have to consider here is that concurrency, right? What happens with concurrency? Now keep in mind that all the thing that we're doing here is really a starting point towards something we're going to be doing next. But if you ever decide to just go into production with this in-memory list of games, keep in mind that this is not going to work very well because games is a simple list, right? So games is a simple list that we have over here. And this list is not thread safe, right? Meaning that if you start getting multiple requests, let's say into put over here, right? You could go and run into issues, right? Imagine multiple requests coming here and trying to modify the same game at the same time. That is not going to be thread safe. That's going to cause problems. So don't do that. In that case, you want to be using something different than a list, perhaps a concurrent back or something like that. Just not a simple list. Now, in our case, we're going for this because, like I said, this is just an initial implementation for you to get started with the REST APIs. And later, you're going to see that we're going to get rid of that list and move into something much more interesting, right? And so let's go ahead and implement our last endpoint. And this is going to be our delete endpoint, right? So let's scroll down here and documentation. This is going to be a delete for the games pad. And then we need to specify some sort of file, right? So just like before, map, in this case, is map delete. And we want to specify where it's going to be the pad. In this case, just games. And then it has to have the ID, of course. And then we specify what is going to be our argument. In this case, it's going to be just the ID, int ID. And then let's open up our Lambda body over there. And let's see what would we do for a delete. But the delete is actually, as you expect, the simplest thing to do. All you have to do is just remove any game that matches that ID. For that, what you can do is just say games that remove all. And then where the game is game.id equals ID. That's all. And then the expectation for the delete is, again, a no content, just like in the update case. So you can do return results that no content. That's all it is. All right. So, and well, to test this, very easy. Let's go ahead and run our server once again. .NET run. Let's go to our file over here. I'm going to grab the location from the previous request. And I'm going to just add here another request down here. Now, in this case, it's going to be delete into whatever path we have over there. And then, yeah, that's pretty much it. Let's say actually we're going to be in game number 2, right? And so now before we delete, let's confirm what we have initially, right? So right click at the very first request. We have 3 games right now, 1, 2, and 3. We're going to be deleting number 2, Final Fantasy 14. So let's right click on, let's close this and right click on our delete request, send request. It says no content, 204 no content, meaning this is successful. So now we can go back and get our full list. Once again, send request. And on the right side, you can see that we no longer have a game number 2. So we have 1, we have 3, we have 2, it is gone. So our deletion is working as expected. All right, let's close this and let's stop our server and back into process. Now, at this point, our API is mostly functional. However, we have only dealt with happy paths, right? So we still need to deal with a few unexpected scenarios. For instance, what happens if we are not able to find a game, right? And let's try it out. So let's go ahead and run our server, all right? And now let's go back into games.http and let's try to find a game that does not exist. So if we go back into our very first request, we know that we have games 1, 2, and 3. That's fine. Now let's use our second request to request game number 4, right? What happens if we request game number 4? So right click, send request. And what we can see on the right side is that not only we're getting a 200 OK, which is already bad, right? Because, I mean, there's no game. Why are we getting a successful result? We're even getting a null response down here. So this is just completely wrong. This is not what we should be returning. There's a standard way to reply for a situation where the resource cannot be found. And that's what we're going to cover. Now let's close this and let's stop our server. And perhaps we can close a few of these tabs here to simplify our screen. Move this here. So let's head back into our get by ID get by ID method over here. So this one over here. So first thing we're going to do is just to give a proper body to this method. So let's open curly brace there. Let's do this. All right, like that. And then what we're going to do is to actually capture the result of the call to find, right? So we're going to say, well, var game equals games.find. Okay. Now, what are we actually receiving from games.find? If we notice closely, we're receiving not just a game DTO, but a nullable game DTO, right? And to make that more obvious, let me just do control dot here on var, and let's use an explicit type as instead of var, right? So this is a nullable game DTO. That means that we could either receive a game, or we could receive null if we're not able to find the game. Because of that, what we can do is to alter the response to our endpoint here to return the correct response depending on if we found the game or not. So we can say is, well, return. We're going to say if game is null, right? So if it is null, we're going to return, we're going to be using the results class to return not found, right? That's a standard response when we're not able to find the resource. And otherwise, if we're able to find the result, the resource, we're going to say, in this case, well, we cannot just say game, right? Because now we are returning two things, right? On one side, we're returning an object of type iResult, and on the other side, we're returning an object of type gameDTO nullable. And that's not allowed. That's why we have these curly braces over here. So because of that, we're going to wrap the game into results.OK. Okay, that will make sure that for both cases, we are always returning the same type of iResult. All right. And yeah, that's pretty much it. So if we run this once again, so let's run the API. All right. So we're running it, games.http. Now let's try to retrieve game number 4 once again, request. And you're going to see that now we get the proper 404 not found. There is no null down here. And this is the expected response when we're not able to find a resource. All right. So yeah, so that fixes the case of our for get by ID request. Now let's see what to do about our put request, right? Because I mean, post is fine, but put could face a similar situation. So if you're not able to find the game, this find index call is going to return a -1. So in that case, we should not move forward and we should return a not found. So what we're going to do is just say if index is actually -1, so that's the response, -1. We're going to say, okay, return results.not found. Now, one thing to keep in mind here is that returning a not found for a put call is kind of is one of the possible things that you could do for put. And it's not really clear in REST terms if this is the absolute truth of what you should return. Because another thing that you could do in this case is just to go ahead and create the resource. If you can't find it, you could go ahead and just create a brand new resource with the payload that we received over here, right? And that's what many services do, but many other services will just return a not found. What to do exactly? It is not clear. It is not clearly defined. So it's really up to you to decide what to do in these cases. Now, I do prefer this way of returning not found because in the case where you actually choose the other option where you create a resource, you run into a bit of a problem when you move into a scenario when you actually have a database that is able to create the IDs for the resources by itself. And in that case, if the ID over here said, well, ID is going to be, I don't know, 5, and then you come here and you cannot find the resource and you go ahead and create a resource, the database will go ahead and create the resource with whatever ID makes sense, right? So it's auto-incrementing usually, right? And that may not match the ID that you specified here, right? So you get into a weird situation of what do we do about that identifier when we're not able to find a resource with that for a put request. So because of that, I do prefer this method here, but you keep in mind that it is totally fine to choose to just go ahead and create the resource if you're not able to find it in a put scenario, right? So let's go ahead and test this. Let's make sure this works. So .NET run, let's go into games.http. And in this case, we're going to go ahead and try to do a put for, let's say, game number 5, which does not exist. Let's see what happens if we try to do that. Right click, send request. And as you can see, we are getting now a photo for not found. So our new logic is working. Awesome. So let's close this and let's stop our terminal. And back to program CS. Now, what about our delete endpoint, this one over here? Should we do something about the fact that the game may not be there? Well, as you can see, it doesn't really matter, right? Because we're just removing whatever we can find that has the specified ID, right? And that's okay for a delete verb. The object of delete is to delete the resource if it is there. If it is not able, we're not able to find it, it is fine. The client doesn't really care of the fact that it found it or not, as long as the resource does not exist anymore after invoking the delete operation. All right. Now, now we have our endpoints pretty much implemented, right? At least the basic behaviors. And then one thing that may be bothering you at this point is that, well, we have, I think, just too much code in our program.cs file, right? So this is just becoming a big file, and that's a big no-no, right? We should be able to put all this code in somewhere else to keep our program.cs as clean as possible. So because of that, what we're going to do is the following. Let's go back into our Explorer, Ctrl-Shift-E, and then let's collapse this. And what we're going to do is just create a brand new directory in Solution Explorer. So again, store.api, right-click, new folder. Let's name this folder endpoints, all right? And in the new endpoints directory, we're going to right-click, and we're going to add a new file, unless this is going to be a class, and this class is going to be named games endpoints. Yeah, games endpoints, that's the name. All right, and as usual, let's do control dot at the very top here to fix our namespace. So it is games.api.endpoints, right there. And let's collapse this. Now, this is going to be what is known as an extension method, as extensions class. Or, I mean, going to be a static class that's going to have extension methods, which are going to be static. And the idea of this class is that we're going to be able to extend one of our classes or classes that we don't own, like the web application class, so that with just one call, we can map all of the endpoints that we need for our API. Let me show you how that actually works. So first, this class has to be static. Okay, so we can have our static extensions methods inside. And then we're going to start transferring all of the code that should not really be in program CS anymore. So we're going to start with this const and the list that we have here. Let me copy this. We're going to copy that over here. All right. And then let's make sure that we import any spaces. I'm going to do control dot on game DTO to use gamestore.api.dtos. All right. So here we have our list. Now, since we are in a class now, we should provide a proper modifier for the type of access that we should have for this games list. So in this case, this is going to be a private list. All right. And we have curly braces here because it is suggesting that we should make this field read-only, which makes sense because even when we may be adding or removing methods into this, adding or removing games into this list, we're never going to be reconstructing the entire list from scratch, right? That's never going to happen. And so because of that, we can make it read-only, right? Now it is a read-only list. Okay. Now we still have curly squiggles here because we are declaring an instance member in what is really a static class, right? This is static class. So because of that, we will have to make this list now also static. And really everything here is going to be just static. Now, with that in place, we can move forward to actually declare our extension method. Like I said, this is a method that is going to extend the functionality of an existing class. And it happens to be a class that we don't actually own, but we can still extend it. So let's do that. Public static. And then we have to decide here what is that we're going to be returning from this method here. And what we're going to be returning is just going to be the exact same time that we're going to be extending, right? As kind of a convention. So that type is going to be web application, all right? That will allow whoever calls this method to just chain another call into another extension method that is also extending web application if they want to. Now, the name of this method is going to be map games endpoints. And then this is going to receive web application, and let's name it just. Now, to make it so that this is actually an extension method, all you have to do is just put this here, and that turns this into an extension method. So now our method is going to show up as a new method of the web application class. Right. Now, what should we put in the body here? Well, let's go to program CS and just grab all of the methods that define all of our endpoints for our API. So all of these, let's copy that, and let's paste those over here. All right. So our method looks like this, map games endpoints, and we start adding all the map gets, map post, map put, and map. Finally, since we are returning a web application object, we should just return app. Okay. And yeah, that will do it for our map gains endpoints extension method, right? We just return app at the end. With that in place, we can now go back into program CS and we can clean things up. So we can go ahead and pretty much remove everything between app and app.run. Or we can just get rid of all of this. And all we have to do now is say app.map gains endpoints, right? So as you can see now, our program CS is very clean. And I'm going to do control dot at the very top to remove unnecessary usings like that. So that's all we have now in our program CS. And now we have our everything that is related to our endpoints in gains endpoints.cs, right? Now, it is possible to further refactor this, of course. You should do that, but in this tutorial, we're not going to go that deep into refactoring. We want to move forward to another set of very important topics regarding REST APIs. And one of those topics here is the fact that if you notice, we have this games endpoint, right, in multiple places across the API, right? So we have it there. We have for the map get by ID, and then we have it for every single endpoint. We have games all over the place. So can we do something to improve that? We certainly can. And to do that, what we can do is just take advantage of something that is known as a group builder, right? So we can create a group that defines common things across all the endpoints so that we don't have to define them over and over. How to do that? So let's scroll down a little bit. And all we have to do here is say, well, our group equals app.mapGroup. Okay, and in this map group, we can say that, okay, so all of my routes for this specific set of endpoints are going to start with games. All right, everything starts with games. And with that, we can take this group variable and make it so that all of the gets, posts, and all of these calls go from group. So I'm going to replace app here with group, and then the same thing for every single method here. So group, and then group, and group. Okay, and since we have chained everything into that group variable, we probably want to also go ahead and return that group down here as opposed to the app. Now, group does not map to web application, so we'll have to change the return type into route group builder, right? So let's go all the way up and let's change from web application into route group builder. Now, of course, what's the point of doing this? Well, the point is that now we don't have to say games all over the place. So in this case, we can just say slash, right? Because this get is going to go just after the games that's over here, right? Still goes into slash games like this, but it's going to be because the get is chained into the group that we created up here, right? So for the second one, we can remove games, right? It's just a slash ID, and same thing here. A post is just going to be like that. For put, is going to be like this, and for delete, same idea, all right? So that's one way to avoid having to repeat the same name over and over, right? So that's what we know as a route group builder. Okay. And then, well, let's make sure that things are still working properly. So I'm going to just run the API and let's just check that we can go ahead and in games.http, we should be able to list all of our games. So let's send a request. So yeah, that seems to be working just fine. And I'm going to just test one more thing, our post, right click, send a request, and it is working as expected, right? So it's all good. Awesome. Now, the next thing that we should work on is, well, what happens if we receive invalid inputs, right? So in this case, like for instance, in the post case, this one over here, what happens if somebody posts a payload without a required element, right? For instance, we should not be able to send, and let me scroll down here, we should not be able to post a game without a name, right? So you should always have a name. What happens if I just do this, right, and send it like this? We're going to try that out. Let me see. Yeah, so my server is running. And so, well, let's right click, let's hit send request, and let's see what happens, right? So notice this. So the resource got created, so 201, no problem. But now notice this, we got a null in the name. So the API allowed us to just create an invalid resource, and that is not good. So in this case, what we should be returning is really a bad request, right? Because it is a validation error, and the input is not correct. So we have to do something to account for those cases, right? So let's close this and let's see what we can do. So let's go back, and this time we can just close program CS and let's focus on games endpoints. Now if you go down into my post, over here, right? Well, there's a couple of ways to deal with this, right? And then I think the manual way to do this is, well, as soon as we receive the post request, we could do something like, well, if string that is null or empty, perhaps new game dot name, right? We could go ahead and say, well, return. We can do results dot bad request, right? And perhaps we can even add a little message here that says name is required, right? So that would be the basics that you can do. If we execute this, I mean, that should certainly work. Okay, so we're running. Let's go back to games.http, right click here, send request, and that works, right? So now we're getting a bad request, which is much better. And we even have a little message down there. So that's okay. However, of course, this is going to start becoming a little bit challenging, right? Because let's go ahead and stop the server, go back to games endpoints, because name is not the only property, right? We have a bunch of properties here to deal with that could have many different kinds of validations that we need to perform in there. So we're going to end up writing a lot of code here. Perhaps we even have to do the same thing for the put request, right? So this is not the best approach. So what we want to do is to introduce some sort of proper validation into our DTOs. And there are a few ways to do that. So here I'm going to show you the simplest and most basic way that you can use in .NET to do validation, and that is by using data annotations. So let's actually undo this. We're not going to be using this really, right? And let's go back into Ctrl+Shift-E, our Explorer. Let's go into Create Game DTO. Here's our DTO class. So what we can do here is to use this concept of data annotations. So data annotations are nothing more than just attributes that you can apply to your properties and that can define what is expected of these properties. For instance, for the name, we can define here that the name is required, right? The name is required. I'm going to do this control dot here to import the system component model that data annotations namespace. And even more, I'm going to say that our names should not be really that big. Let's say that our name should be at much, let's say 50 characters, right? Nothing more than that. So we can do string length of 50, like that. Okay. So with that, anywhere we use this create game DTO, that validation should be automatically applied. That's the idea behind this. Okay. And then for the genre, let's do something similar, but let's do perhaps the genre doesn't have to be that long, perhaps only 20. That will be good enough. And then for the price, well, price is not a string, but perhaps we don't want to accept the prices of, I don't know, thousands or millions or even more than that. Perhaps we can say that the price should be in a range of 1 to 100. That should be good enough for the price. We don't have video games that are more than $100 of price. I mean, that would be crazy. And yeah, that's pretty much it. So that defines the data annotations for the creation of our case, right? And this is, remember, the create game DTO is the one that we receive here in the post. However, that's not going to be quite enough, right? If we just go ahead and run this, okay, run that, and we go into games.http, if we go ahead and now run this post request, send request, it still is not doing the validation, right? So notice that we still get created, we still got the null there, so it's not working. So those data annotations will work just fine in the older ASP.NET Core MVC framework, but when you do minimal APIs, you need a little bit of more support. And at this point, what you want to do is to use a new feature called endpoint filters. Endpoint filters is a feature that comes with minimal APIs and allows you to validate what's coming into your endpoint and do some sort of validations around it, right? Now, and let me just close this and let me stop my server. Now, we could use endpoint filters manually ourselves, but there's actually a better way. So there are NuGet packages that already wrap the right endpoint filters that can tie directly into the data annotations that we're using here so that we can easily enforce these validations, right? So what I want to do is to show you a NuGet package that you can use to automatically perform the validation. So let's actually go into NuGet.org. And by the way, if you're not familiar with NuGet, NuGet is pretty much the package manager for .NET. And so there are hundreds and hundreds, probably millions, thousands or millions of NuGet packages already available that can simplify many things for you, so you don't have to write your code manually. So in this case, we're looking for a very specific NuGet package. And let me show you here. So I'm going to just type here minimal APIs.extensions. Right? So search for that. This is a free NuGet package. Well, everything is free really here. Open source NuGet package that is able to help us in this case. So I'm going to grab the latest version here. I'm going to just copy the command here for .NET CLI, copy that, and let's go back into VS Code. So I'm going to open my terminal, and I'm going to just paste that line. So .NET package, minimum APIs are extensions. In this case, I'm using version 0.11.0 and hit enter. All right. And so at this point, if we take a quick look at our, let's see, GameStore.api project, this is our project file, csproc. Notice that now we have our first package reference. This means that now our project is able to use any of the types, classes defined inside that NuGet package. And because of that, we can do the following now. So let me go into games endpoints. Now, under our post over here, we can go ahead and say, just before ending, we can say dot with parameter validation, which is one of the methods provided by that NuGet package. Okay, and just by doing this, the appropriate endpoint filters are going to be applied and are going to recognize these data annotations that we specified in create game DTO. So now if we just go ahead and run our API, okay, it is running, back to games.http. Let's execute our incomplete request, send request, and notice that not only we get our bad request as we should, we even have a nice error message down here. So let me show you. Nice error message that says, okay, so one or more validation errors occurred. We have a status 400, and it even tells us exactly which field is missing, right? And so, and this is very nice. And in fact, this is actually tied to the proper RFC that you can see over here, which is the right way, the standardized way to report errors back into clients, so that clients can easily read these errors and act accordingly, right? And we were able to do all this just by using one NuGet package, right? Now, if we go back into the code, one thing that you should realize is that you can do this parameter validation not just for one endpoint. You can actually apply it for all of the endpoints by using your route group, right? Remember that we have a group here, this group over there. So what you can do now is just say, actually we can just change it here. We can say dot with parameter validation. And now these validations apply to any of the endpoints that are going to be receiving one of these DTOs that have data annotations, right? And in fact, we are doing validations right now for create game DTO, but we should do the same thing for our updates, right? So they should also be validated. So let's open up update game DTO. And then, well, I'm just going to go ahead and copy this because it's pretty much the same validation we're going to apply right there. Same validations. Let's make sure that we import the right namespace. And now both create and update should get validated. So let's go ahead and run our API. Let's make sure that all of these validations are working properly, right? So let's go back into games.http. So we already verified the create for an empty name. Now, what happens if we try to do a very long name, right? So Minecraft, big name like that. So I'm going to right click here, send request. Okay, let's see. Notice the error now. The field name must be a string with a maximum length of 50, right? So the length is getting validated for that request, which is correct, right? Let's go back to this. What happens if we have if we don't have a genre? Let's see, right click and then send request. Yeah, the genre field is required, so that's good. And let's do something about the price, right? We said that the price should be at much 100. So let's see if we try a price of 119.99, right click, send request. And as you can see over here, the field price must be between 1 and 100. So that's all working just fine. And lastly, let's go ahead and verify that our put is also validating, right? So let's remove the name from the put and let's use a valid ID. Let's do ID 2, right click, send request. And as you can see, once again, we get a bad request over here. And if you go down there, yeah, you can see the name field is required. So yep, it's all working as expected. So now we have properly validated endpoints. All right, so let me go ahead and just stop our server, okay? And with this in place, I think it is time to start moving away from this in-memory list of resources and actually introduce a proper database for our REST API. And to do that, we're going to be using a very handy framework that is part of .NET that is known as Entity Framework Core. So let's switch briefly into slides to learn more about Entity Framework Core and why it's going to be super useful for our development here. In this section, you will learn about the object relational mapping technique and how Entity Framework Core can help you write code that interacts with your database without having to learn a new language. At this point, we want to add database support to our REST API so that all our data is persisted beyond the lifetime of the application. So whenever a request to create a game is received in our API, we want to create that game in the database. And when the client requests a list of games, we want to query that list also from the database. However, there is a problem. The database does not speak the same language as your ASP.NET Core API. Your API is coded in C#, but your relational database server only understands the SQL language. That means that to fulfill that request to retrieve games, your C# code needs to translate the API request into a carefully crafted SQL query, and then send that query to the database server. The database server executes the query, and then your C# code has to read back any resulting rows and translate them into a corresponding API response. This presents a few problems. As a C# developer, you now need to learn a completely new language, SQL, in order to craft the required queries. And you need to learn it well to ensure you get good performance out of it. You'll need to write a lot of additional data access code whose only purpose is to translate things from C# to SQL and vice versa. And of course, deal with unexpected errors. Talking about errors, this approach is error-prone, since it's very easy to make mistakes when mapping things from one side to the other. And you need to manually keep your C# models in sync with the corresponding database tables, which can be quite challenging. This is where Object Relational Mapping Techniques, or ORM, can make a big difference. But what is ORM? Well, going back to our Spotify example, imagine your application has been created using an object-oriented paradigm, and therefore it includes objects to represent songs, artists, and playlists. And if you're working with a relational database server, there's a good chance your database will have corresponding tables for each of those objects. Now, instead of having to write custom code to map these objects to tables each time you need to send or receive data to or from the database, you can set up a map between them so that your program can keep working with objects while another component, an object relational mapper, takes care of transforming objects to tables and vice versa. So, in essence, object relational mapping is a technique for converting data between a relational database and an object-oriented program. And as you can imagine, it brings many benefits to application developers. And fortunately, ASP.NET Core includes a great ORM framework called Entity Framework Core. So, what is Entity Framework Core? It is a lightweight, extensible, open source, and cross-platform object relational mapper for .NET. Entity Framework Core will sit between your REST API and your database server. Besides mapping your .NET objects to database tables, it will translate your C# data access code into SQL statements that the database server can understand. And it will also translate any resulting data from the database into objects that your API can easily manage. Using Entity Framework Core in your .NET applications brings in multiple benefits. There's no need for you to learn a new language. You can perform all data access tasks using your familiar C# language. The actual data access code that you need to write is minimal, since Entity Framework takes care of most of it. In fact, you can use Language Integrated Query, or LINQ, to perform most of your database queries. There's tooling available to keep your C# models in sync with your database tables, so you don't need to do this manually anymore. Entity Framework can keep track of the changes made to your C# object instances at runtime, so it knows what changes to send to the database when it's time to persist the data. Also, Entity Framework Core supports multiple database providers, so you can use your same C# models with other relational databases if needed. Let's now see how to use Entity Framework Core to add database support to our Game Store REST API. The first step towards adding database support into our API is to define the class or classes that are going to represent the data model of our application. Now, could we just go ahead and use our DTOs for that? You could try to do that, but in general, that's really a bad idea. Remember that the DTOs represent the contract between your API and the clients, right? And that should rarely change. However, what we want to define now is the data model. So this ties directly into the database tables that we're going to be using in our database. And we want to have the flexibility to change those tables and to lay them out in a relational structure that may not match those contracts, those DTOs that we have already defined. Okay, so because of that, and to have this flexibility, we want to keep those separate, right? So let's not touch the DTOs at this point. And instead, let's go ahead and in our Solution Explorer, let's create a brand new directory, which we're going to name as a new folder. Is going to be entities. Okay, the entities are going to represent our data model. And then let's right click on entities and let's add a brand new file. And this is going to be a class. And this first class is going to represent not our games, but actually our game genres. Because in our database, we don't want to just store simple strings for every single game, right? For sports, racing, and all that. We want to have a proper table with all of the game genres and then have a relation between our games and our genres. So let's define first our genre table or our genre entity right there. Okay. And for this class, and let me collapse this for a bit, yeah, right there. For this class, first, let's go ahead and fix our namespace as usual, like that. We're going to have just two properties here. So we're going to do prop, and then this is going to be an int, is going to be the ID, and this, the second one, is going to be string, the name. Now, we do have a small warning here, right, for name that says non-nullable property name must contain a non-null value when exiting the constructor. What this means is that we have declared a variable that is not nullable, right? It's a simple string, not nullable string, and yet we have not defined any default value for this property, right? And so the compiler is complaining about this, and it's asking us to provide some value or declare the variable as null. So there's a few ways to fix this. You could start by just doing like something like this. If you wanted to, that will initialize the variable as an empty string. Another way to do it would be to say, okay, so this is actually going to be a nullable string like that. But we don't really want to have nulls in our genre names, right? So a better way to do this is by actually using the required keyword over here, required. And by doing that, you're saying that whoever goes ahead and constructs instances of genre will have to make sure that they provide a value for name when they construct the object, right? Whichever way they use to construct the object, they have to provide a value for name, right? So that's a very handy way to deal with nullables in C#. All right. So now that we have a class for the genre, we have to define another entity, in this case for the game. So let's right click again on entities, new file, class, and this is going to be our game. Okay, once again, let's fix the namespace like that. And let's go ahead and define the properties for our game. So if you remember, we should have here an ID. Then we should have our name. So this is going to be our name. And same thing, we want to define the name as required, just like this. It's required. Scroll down a little bit. And then we need to define the genre. But now, as you know, we are going to be using a relational model to associate the game with the genre. Because of that, we're going to have to do two things. The first thing is that we need to define a property to represent the ID of that genre that's associated to the game. So what you can do is just say genre ID. Okay, so this is the ID that is going to be connected to the ID of genre in the genre entity. But we also have to specify another property here of the type of genre itself. So it's going to be prop type genre, and let's just call it genre. Now, this property here may or may not be null, right? Depending on if we decide to populate genre when we read data from the database via Entity Framework. We may decide to populate genre or not, right? Sometimes it may be just enough to have the genre ID, so that will be populated, but not the genre. So since it's not clear at this point if we are going to have for sure a value all the time. So we can totally go ahead and just declare this as a null, just like that. Okay, sometimes we'll have it, sometimes we will not have it. Okay, so this combination of two properties is what you do on Entity Framework when you want to do an association, in this case, a one-to-one relationship between game and genre, right? And so let's scroll down a little bit more, and then let's go for our price, which we know it is decimal. That's the price. And lastly, let's go for our date only, release date. And with that, we have defined the two entities that represent our data model. Now it is time to add proper entity framework support into our API. And for that, we're going to be needing a NuGet package. So let's go into nuget.org over here. Okay, and we're going to be looking for a brand new NuGet package. So let's search for Microsoft.Entity Framework Core.SQLite. So SQLite is the database engine that we'll be using for this tutorial. Okay, it's going to be the first hit over here. And keep in mind that you could be using really any other relational database here, like SQL Server if you wanted to. But for this tutorial, I'm keeping it very simple with SQLite. It's the one that lets you get started very quickly. But most of the code that you're going to see me writing from here on is going to apply the same way to other relational databases like SQL Server. The only thing that changes really is what provider you use for Entity Framework. In this case, we're going to be using the SQLite provider. If you wanted to use SQL Server, you can just change SQLite for SQL Server, right? And now you have a provider for SQL Server, right? Now in this case, let's go for SQLite. And I'm going to copy, not the 900 previous, let's go for a stable version. In this case, I'm selecting 802. I'm going to copy this. Let's go back into our code. Okay, and let's just paste .NET add package, and collapse this. Microsoft Entity Framework Core.SQLite version 802. All right, so now our API is ready to take advantage of Entity Framework. Now let's close this terminal and let's close this. So let's go back into our Solution Explorer in this case. And what we're going to do is create a brand new directory to store any of our data-related classes. So let's right-click on GameStore.api, new folder, let's name this one data. And then in our new data directory, let's go ahead and right-click. We're going to be adding a brand new file. It's going to be a class. And this class is going to be what is known as a DB context. Now in this case, let's go ahead and name it Game Store Context. Right? Game Store Context. Let's collapse this and let's just fix our namespace very quickly. Change namespace to GameStore.api. Now Game Store Context should inherit from DB context. DB context. Okay. Now notice that this imported Microsoft Entity Framework Core. This is a new imported namespace. But well, you may be wondering, well, what is a DB context, right? So DB context is really an object that represents a session with the database and that can be used to query and save instances of your entities, right? So this is the intermediary. So if you're familiar with either the repository or the unit of work patterns, the DB context is a combination of both unit of work and repository, right? Now, to properly construct your DB context, you're expected to receive here, you should receive what is known as DB context options. So DB context options of the type of your DB context. So in this case, Game Store Context, right? Let's just name these options. Okay, and let's send this to the next line. Let's send over those options to the base constructor, like that. So those options are the ones that are going to provide the Game Store context all of the details about how to connect to the actual database, all right? Now, the next thing that we're going to need in our Game Store context is some sort of representation of the objects that need to be mapped into our database, right? And so we know we're going to be dealing with games and with game genres, right? So because of that, we're going to do the following. We're going to declare prop, and it's going to be of type dbSet. So dbSet of type of the actual entity here. So this is going to be game, that's the entity. And we can name this one games. Okay. Now, what is a dbSet? Well, a dbSet is really an object that can be used to query and save instances, in this case, of game. So any link queries, a language integrated queries against a dbSet, in this case of type game, will be translated into queries against the database, right? And to provide an initial value for games, what we can do instead of this is just point directly into, we can use this method set of type game. Okay, that's going to create our dbset instance. All right, and just like this one, we're going to create another one, dbset of type jet, and let's name it jets, which is going to point to a set of type jet. Our context is ready to go ahead and map our objects, our entities, into proper database tables. But what we have to do now is to tell our application how to connect to the database, to our SQLite database, using this GameStore context. And for that, we have to register the context on startup. So let's go ahead and go back into our Explorer view over here. And let's go into program.cs over there, program.cs. And here's where we have to start using our builder object to register services, right? So down here, what we can do is the following. First, let's go ahead and define a connection string. So let's just name it constring. It's going to be, so how do we actually connect to SQLite? So it's actually super simple. This is what I really like SQLite. All you have to do is specify here data source equals, and here you specify the physical path into your database file, right? So in this case, let's just call it gamestore.db. Okay. Now here you could specify some other path into gamestore.db if you don't want to have it directly at the root of your project. But for the case of this tutorial, I think it's just fine to have it directly under the project directory. Right? But you can specify really any other physical path. So yeah, that's a connection string. And with that connection string, we can go ahead and actually register the services. And to do that, what you want to do is just say builder.services. And then in this case, add SQLite. And here we want to specify the name of our context, the one that we just created. So game store context. And then we want to pass in the connection string. Okay. Now this is taking advantage of a mechanism that is known as dependency injection, which we're going to be talking about later in the tutorial. But the important thing to know is that because we are adding these services here, Entity Framework is going to take care of reading this connection string, right? And then it is going to create an instance of our GameStore context, and it's going to pass in DB context options over here that are going to contain all of the details that are in that connection string so that it can connect to our database, right? And map the entities to tables. However, there's one thing that's not really ideal here, and that is that we have the connection string right here in the code, right? Now, in this case, it is SQLite. The connection string has nothing really wrong there. I mean, there's no secrets, no credentials. It is incredibly simple. That is fine. However, it's still not really great to have the code for the connection string right here, because as you change into another environment, let's say into a production environment, you're going to have to change your code here, right, to point to an actual production database. And that's just not ideal. So you want to keep this information, this configuration data outside of the code base. So to understand where we should be putting this connection string, let's go ahead and back into the slides to understand more about the ASP.NET Core configuration system. At this point, we have hard-coded the connection string to talk to our database directly in our application code. However, this is not ideal, since eventually, when we move the API to a different environment, like in a cloud deployment, the connection string will be different, and we would need to make code changes, which is not ideal. Fortunately, there are better places to store application configuration. One of the most popular options in ASP.NET Core, especially for local development, is the appsettings.json file, which can store all sorts of configuration information in JSON format. Now, the appsettings.json file is what is known as a configuration source. And just like that one, there are several other configuration sources supported in .NET applications, like command line arguments, environment variables, user secrets, and even cloud-based configuration sources like Azure Key Vault. And the great thing about this is that the ASP.NET Core runtime takes care of combining information from all available configuration sources into a single configuration object that implements the iConfiguration interface. This configuration object is easily accessible to your REST API in such a way that it doesn't really need to know where the configuration data actually comes from. In this tutorial, you will use the appsettings.json file to store your connection string. But keep in mind that this is an acceptable option only because you don't need to use any credentials to connect to your SQLite database. If, For local development purposes, you are using a database server instance that requires credentials, please use the user secrets configuration source instead, which is enabled by the SVNet Core Secret Manager. Never store any kind of credentials in your app settings.json file. Let's now update our REST API to read the connection string from the app settings.json file. Let's see how to take our connection string out of program.cs and into our app settings.json file. So let's go ahead and open app settings.json. And what we want to do here is to introduce a brand new section that we're going to name connection strings. Now, this very specific element called connection strings is a well-known element of .NET, meaning that there are APIs that are going to be looking specifically for this one word here named connection strings. So make sure that you type connection strings just like I'm doing right now. Now, inside this element, you can introduce one key for each of the connection strings that you want to introduce into your code. Now, in this case, we want one connection string for our game store database. So I'm going to just type here game store. You can really type any name here, but just make sure that it's something that's related to your database. Okay, and then on the right side, we want to introduce the actual value for this key. Now, what value we're going to use, let's just go to program.cs and copy the connection string that we have been using so far. Okay, and then let's paste that over here. All right, so now the connection string is outside of our code, and we go back into program.cs, and like I said, there are APIs specifically designed to read these connection strings. And let me collapse this for a moment. And what we can do now, instead of just reading the hard-coded word, is use the builder object to get access to the configuration object over here, which is the one that implements iConfiguration, and is the one that collects configuration information for every single configuration source that has been configured for your application, like I mentioned in the previous lesson. Now, in this case, this is going to include our app.json file, and because of that, we can just say get connection string. Then we pass in the name of the key of our connection string. So in this case, in app.json, we remember that that is game store. So I'm going to copy game store, and I'm going to paste that over here. All right. And that's really all you have to do to read your connection string from app.json. Now let's confirm that this is actually working by placing a breakpoint over here, perhaps in line 7, to see what value we read into constring. So with that done, I'm just going to go ahead and press F5 to start a debugging session. So F5. And this should be one of the first lines that is hit as the application starts. All right. So the breakpoint has been hit. And so let's see what value we have for connection string. As you can see, data source equals gamestore.db is exactly the value that is being read from our settings.json file. All right. So that is working perfectly, which is great. So let's just stop this debugging session. Now, at this point, our application is pretty much ready to talk to our database. However, the database itself, this SQLite database, does not exist just yet. We need to go ahead and create it. And to do that, we can use a process that is known as migrations. So this is the entity framework process that takes the different entities that make up your data model and turns them into corresponding tables in your database that are properly mapped to those objects. And before we can do that, we're going to need to install one additional tool. So let's go back into our NuGet page over here, and let's look for a tool called .NET EF. Okay, this is going to be the first hit over here. So .NET EF is a tool that you can use to do all sorts of entity framework related tasks against your application. Now, in this case, I'm going to pick version 8.0.2, which is the latest stable version at the time that I'm recording this. So I'm going to just copy this command, and let's go down here, VS Code, let's open our terminal, let's switch to gamestore.api, and let's just paste that command. Okay, so this line here is going to install .NET EF. This is not just a NuGet package, it is an actual tool that you can use to execute entity framework related commands. So I'm going to hit enter. Notice that this also installs the tool as a global tool, right? That's why we're using global over here, meaning that you can now use it from any .NET application that you have in your machine. Now, the next thing that we're going to need is an additional NuGet package. And so let's go back into NuGet Gallery, and let's look for this package called Microsoft.entityframeworkcore.design. Now, this package here is the one that is going to be used to actually generate our entity framework migrations. So let's go down here, let's pick our latest stable version, 8.0.2. I'll copy this, and back into VS Code. I'm just going to paste that here, hit enter, and the package is now installed in our API project. Right? Let's close this. So now we're ready to generate our first migration. Now we have to decide where we're going to generate this migration. If we look at our Explorer over here, what we want to do is just to generate a folder under our data directory. We're going to place a new folder which is going to contain our migration, which is going to have all of this mapping code between our C# code and the database, right? So to do that, let's go ahead and open up our terminal once again. I'm going to clean this. And perhaps let me expand this a bit more so we can see better. So make sure that you are in the gamestore.api directory, this directory over here, and then you can execute the following command. You can do .NET EF migrations add initial create. You can use any name here. This is just the name for the migration that we're creating. Since it is the very first migration, I like to call it just initial create, but you can use any other name. And then we're going to give it the output here. It's going to be under data, like we said, the data directory. And then under that directory, let's create another one called migrations. All right, let's go ahead and execute this. Okay, like I said, it is built, and then the migrations execute. Now, what actually happened here? So if we go back into our Explorer, let's close this. Now we should have under data, as you can see, now we have a brand new migrations directory over there. Open up that, and you're going to see a few new files. I'm not going to go into all the details of these files, but one thing that we can take a look at is this very first file, initial create. Notice that this is going to have kind of a number that is somehow related to the date and time that we are generating this migration on, right? And so if I click on this file, let's see what we have here. So as you can see, so this is a class that extends from migration. It's called initial create. And this is going to have the following methods. So first, it's going to have this up method, which is the one that is used to move to the next migration that the database is missing, right? So this is known as the up method. Then, but we're also going to have a down method that could be used to go back to the previous state of the database. Now, if we go back into our up method, notice that here is where the actual tables are going to be created, right? So migration builder, create table. Here is the name of the table, generous, right? Because our DB context defines this generous DB set. Then generous is going to be created as a table. And here are the columns for the table, right? Which are going to be created in the context or in the terms of the database server that we're using. In this case, we're using SQLite. So because of that, it is creating a table with a type integer for the ID column, and then with a type text for the name column, right? It also sets up a primary key for the ID field in the generous table. And then we move on into the other table, the games table over here, that defines an ID, name, genre ID, price, and release date, right? With corresponding values for each column. Notice also that the ID is going to be an auto-incrementing column, meaning that anytime we insert a value into this table, a brand new number, sequential number, is going to be assigned for the ID. Okay. Then we also have our constraints here. We have a primary key for the games table on the ID column. And we also have a foreign key that relates our games table to the ID column in our genre table. That means that every ID that we use for genre ID in our games table has to exist in the genres table, all right? That's a foreign key constraint. Lastly, we are creating an index for the genre ID column in the games table, all right? And like I said, in down, what's going to happen if we decide to go back into a previous version of the database, it's going to just go ahead and drop the games table, and then it drops the genres table in the proper order, all right? So yeah, so that is the migrations process. And now our code base is ready. I mean, the code base now knows how to go from nothing and into the actual database. So what we have to do now is to execute this migration so that it gets applied into the database. So let's see how to do that. Let me close this and this and this. And let's go ahead and open our terminal here. Let's clean this. And really all you have to do to execute the migration is to use, again, .NET EF. And in this case, the command is going to be database update. So let's hit enter. So .NET Entity Framework is going to locate that migration code, and it's going to execute it against our machine right away. So let's take a quick look at what's going on here. So you're going to see a bunch of Entity Framework related commands but you can see how the table the tables get created. Now, the first table, as you can see here, in this section here, is the EF migration history table. So this is a table that's going to be used to keep track of what migrations have already been applied into your database, right? That's how Entity Framework knows what is missing from your database if you add new migrations later, right? So that's the EF migrations history table. Now, if you keep going down, we're going to see that here's where Entity Framework notices that we have to go ahead and apply this brand new migration that we created. That's what's going on here. And then later, it goes ahead and creates the genres table, as you can see, creates the genres table. And then we keep going down, and it will go ahead and create our games table right here. Right? And then it will end up creating the indexes. And finally, it sets a brand new value into EF migrations history for the brand new migration that we just executed. Right? So that happened, seems like it was a success. Now, how can we actually take a look at that database and make sure that it got actually created, right? So let's go back to our Explorer view over here. And one thing that we're going to notice now is that we have a brand new gamestore.db file over there, right? Now, the reason why this file, which is a file for our SQLite database, got created directly under our gamestore.api directory is because of how we define our connection string, right? If we go back to absence.json, I'm going to close this. Remember that we said that the file would be just in gamestore.db, which mapped directly into the root of our project. Now, if you wanted to, you could move this file somewhere else. Like, for instance, you could do something like, I want to have a .db dir like that, and that will create that will place the database into that .db dir under your project directory. But just make sure that, be aware that you have to create this directory manually before doing that. Otherwise, Entity Framework will not be able to create your database, right? Now, since it's just for local development, I think it's just fine to keep the database like this. But one thing you may want to do, if you're using Git, for instance, is to make sure that you exclude this file from your Git commit, right, on Git ignore, so that the file does not get checked in. Right. So now we have our file over here, but how do we actually get into it? Now, remember that we installed this SQLite extension for VS Code. That means that we have the ability to peek into that database. And to do that, let's just right-click in gamestore.db, and let's use this very first element over there that says Open Database. Click on that. And by doing that, notice that a brand new Explorer showed up over there on the left side, SQLite Explorer. So that is going to allow us to start looking into what's going on in the database. And if we start expanding these nodes here, we're going to see the structure of the table, right? So we have genres with an ID and a name. And then we have games over here with an ID, name, genre, price, and release date. There. Lastly, we also have, like I mentioned, we have our EF migrations history table right there, which, like I said, this is the one that keeps track of every single migration that we are executing against the database. Now, if we just right-click on the EF migrations and we select Show Table, that's going to show us the current set of values inside that table. As you can see, there's just one value over there, and it even keeps track of the version of Entity Framework that we're using so far. All right. So yeah, so our database now exists, and our application is ready to start working with it. Now let's go ahead and close this, and let's go back into our File Explorer. Now, one thing that I like to do to simplify things a bit is to have a little bit of code on startup that takes care of applying any missing migrations when the application starts. That way, we don't have to run the Entity Framework command to update the database every single time that we add new migrations. So let me show you how to add some of this code so that the migration just happens as soon as the application starts. All right. So under our data dir, and let me actually switch into Solution Explorer now. Under our data dir, I'm going to right-click and add a brand new file. Okay, it's going to be a class. And this one, let's name it just data extensions. Okay, so this is going to be an static class to hold a brand new extension method. So let me now collapse this. Oops. Let's just go back to the file right here. Okay, so let's fix our namespace. Control dot, let's fix it to gamestore.api.data. And like I said, this is going to be a static class because we want to put an extension method here. And let's introduce a brand new method here that we're going to name, going to be static because it is extension method migrate db. Okay, and this method is going to extend the web application object, web application class, all right? And what we want to do here is to go ahead and migrate the database. So there are APIs in the framework to go ahead and migrate your database. However, everything that has to do with our database needs to have an scoped lifetime. And we're going to be talking about dependency injection and these lifetimes in a moment. But for now, what we need to know is that we cannot just access the DB context directly. We need to provision a scope that allows us to actually start interacting with the database, right? So let me show you how to do that. First, we're going to be getting an instance of a scope. So to do that, let's do this. Using var scope equals app.services.create scope, right? So that gives us a scope, and let's see what type is this. This is an iServices scope, right? That we can use to request the service container of ASP.NET Core to give us an instance of some of the services that have been registered in the application. Now remember, if you go back into program.cs over here, program.cs, we have executed this line here, right? At SQLite. This line here is going to register our game store context in the service container, right? Meaning that ASP.NET Core knows about the type and is ready to provide us an instance whenever we request one, right? So if you go back into the extension, what we can do is the following. We can now say db context equals scope service provider that get required service. What service we need? We need the game store context service. Okay. And like I said, we're going to be talking more about this dependency injection and service scopes in a moment. But for now, let's just use our DB context to get access to our database. And from there, we can access the migrate method over here, which, by the way, imported a brand new namespace at the top over there, Microsoft Entity Framework Core. All right. And with these few lines, we are now ready to execute migration on startup. Now, all we have to do is go back into program.cs and invoke that method. So I'm going to do that actually close to the end, just after map games endpoints. I'm going to just say app.migrateDB, right? We can use this method because it extends our web application object over there, all right? Now, to verify that this actually works, what I like to do is just to, well, delete the database, right? Delete the database, and the application, when it starts, it should go ahead and recreate the database automatically, right? This is one of the reasons why I like to use SQLite for learning purposes, because it's very easy to just right-click on DB here and delete the database, right? Yep, delete. It's gone. Okay. Now let's go back into our terminal over here. I'm going to clean this, and I'm going to go ahead and do .NET run, and let's see what happens. Yep. As you can see, all of the statements to go ahead and perform the migration executed. As you can see over here, all of the statements executed just before starting the application, and GameStore.db is right there regenerated. All right. So yeah, that worked just fine and simplifies a little bit the way that we execute these migrations. Now, one thing that I don't like, and let me just stop my server for a moment, is having so many statements every time the application starts, right? Because from here on, anytime the application starts, Entity Framework is going to be logging whatever it is doing to our database if needed. So one thing that we can do is to simplify a little bit these logs, right? So we don't have to see so much, right? It is fine if we need to, but logging can get very verbose. So how do we actually switch this logging a little bit so that we don't have to see so much every time it starts? So let me cross this. Let's go into absence.json over here. And what we can do is to add just one more entry into this section, logging, which is the one that configures logging for our application. We can add one more entry to change the login severity of one of the elements of our application. So for instance, in this case, if we go back into the terminal, right? For instance, all of these statements that says, hey, I'm executing this command here and this command there, right? I think that's just too verbose, like also here. But all of those statements are coming from this one namespace. Look at this, Microsoft Entity Framework Core.database.command. So what we can do is say, hey, for anything that comes out of the Microsoft Entity Framework Core.database.command namespace, please only show me warnings or errors, right? Or something critical. But do not show me just information messages, right? These are all info. As you can see on the left side, these are all informational messages. What I'm going to do is just copy this. Let's see if we can copy. Close this. And I'm going to add an entry into here to configure a different log level for that very specific namespace. Right? I'm going to say that for this one, I do want to use warn. Okay? And by doing that, I'm saying, hey, I only want to see either warnings or errors or something critical, but not anything that is really less severity than that. Okay? So if you now go back into the terminal and let me actually open my Explorer, I'm going to delete the database once again. Let's see what happens different this time. So I close this. Let's clean our screen and let's do .NET Run. Notice that now the output that we got here is way different, right? There is no mention of all of these commands that are executing in there. All that we are going to see here is this line here that says applying migration, something, something. And then if there was any problem with that migration or with any of the commands, it would show up here. But otherwise, the console, it is just very clean, right? There's not much going on there. So doing this is something optional. I mean, if you want to see all those commands every time, just feel free to not do what we just did in absent.json. I just like to keep our command line as clean as possible. All right, so let's stop our server and go back to our code. Just close all of that. And let's go back to our file explorer. Now, as you know, we have this concept of game categories in our application, right? So things like sports, racing, role playing, and all that. And for those values that are which are pretty much fixed across the application, we're not going to be creating APIs to create or modify the categories. We're just going to go ahead and populate the categories when the application starts, right? And to do that, we can use a very simple process of data seeding that we can introduce directly into our game context or game store context object. So let me show you how to do that. Let's go into our data directory and into our game store context over here. And what we're going to do, if we scroll down a bit, is to add a brand new method just under our latest DB set. And let's go ahead and override. We want to override the onModelCreating method, this one over here, onModelCreating. All right, so let's scroll down. And this is one of the methods that are going to be executed as soon as the migration is executed, right? So when you execute the migration, this code over here is going to execute. So this is an opportunity for us to do things that slightly modify the model according to our needs. And one of the things that we can do here is to populate some very static data, right? Now, I would not do this for data that requires much more complex operations, right? This is just for some things that are very, very simple. And like I said, this is just a list of categories. Now, to do this, what you have to do is just say model builder dot entity, and then the type of entity is genre. And then we're going to be using the method called has data, right? So this is going to make sure that whatever data we introduce here has to exist when the migration process completes. Okay. Now here, what you want to do is to introduce, well, as many elements as you need for, in this case, for the genre. So for instance, I can say new, and then I'm going to say, well, ID equals 1, and this is going to be our name equals, and the first category is going to be, let's say, fighting. All right. So there we have our first element. And let's go ahead and spin up a few more categories. I'm not going to just type all of them. Let me grab them from my other screen here. Now we have 5 categories that we can work with, right? So fighting, role-playing, sports, racing, kids and family. And feel free to use less or more of this as you want. But yeah, so just by having this code here, all of these 5 categories are going to be created as the migration executes. So now for that to work, we of course need to add a brand new migration, right? Because otherwise, Entity Framework doesn't know that it needs to map this to the database. So to do that, let's go ahead and open up our terminal and let's add a new migration. So .NET EF migrations add, and now we want to use a new name for this migration. So let's say seed generous, right? And once again, the output here is going to be under data migrations, right? Let's go ahead and hit enter. All right, migration completed. Let's see what happened on our Explorer. Over here, migrations. Now we should have a brand new file. As you can see, we have seed generous right here, seed generous. Let's click on that one. Let's see what happened over there. Now here we have a brand new up method. So here's up. And then Here, the migration builder is executing the insert data method over there to go ahead and into the generous table is going to insert these 5 values. All right. So that's all we have to do. And for the down method, it will go ahead and delete all of those values that it got inserted. All right. And once again, like I mentioned, I would only do this for very, very simple data that does not need to interact with any other objects in the application. Because remember that you're not actually running the application at this point. You're just doing some static work as you're applying the migration, right? So only for very simple stuff and static data that is not going to really change. So if we go ahead and run the application now, right? So .NET run, runs application, okay? Notice that the new migration got applied over there, see generous, got applied. And if we go into our database, okay, let's collapse this. Let's go into our GameStore.db, actually SQLite Explorer. If we go ahead and right click on generous, I'll say show table. Let's see what we have. Let me collapse this. Let me close that and that. As you can see, here we have our 5 generous now as part of the actual table, right? So they're right there is live data that we can now use in our application. All right, so that is complete. Let me go ahead and just stop my server. Now we are approaching the moment where we actually need to start changing our REST API to take advantage of our new DB context and all this entity framework stuff. But before we can do that, it is very important to understand this concept of dependency injection, because remember, per MCS, we are using dependency injection to register the game store context into ASP.NET Core. But what does that registration mean, and what is all of this dependency injection concept about? So let's switch to slides so we can better understand the concept of dependency injection. In this section, you will learn about the dependency injection design pattern and the multiple benefits it brings in to your applications. To understand what dependency injection is, let's start by looking at 2 classes, myService and myLogger. myService uses the logThis method of myLogger to log messages to a file anytime myService performs an important operation. Since myService uses some of the functionalities of myLogger, like the logThis method, we say that myLogger is a dependency of myService. Now, in order for myService to start using myLogger, it creates an instance of myLogger in its constructor. And after that, it can start calling the logThis method. At first glance, it doesn't look like this presents any problems. But consider what happens when the authors of myLogger decide to slightly modify it so that a new myFileWriter object needs to be passed on its constructor, because that's where the output file is now defined. The required changes look simple to implement, but they reveal a few important problems. myService is tightly coupled to myLogger in such a way that anytime myLogger changes, there's the need to also change myService, as it happened here when the constructor started requiring a myFileWriter instance. myService needs to know how to construct and configure the myLogger dependency, like is the case here with the myFileWriter object, which needs to be configured with an appropriate file to send the output logs. This makes it hard to test myService, since unit tests won't be able to mock or stop myLogger. An output.log file will always be created, which would slow down tests, and this assuming that the tests have access to a place to write files to. Fortunately, there's a better way to do this using what is known as dependency injection. Let's go back to myService and its myLogger dependency. myService still uses the logThis method, but this time, myLogger is not explicitly constructed by myService. Instead, myLogger is passed in as a constructor parameter. myLogger is injected into the myService constructor. This way, myService doesn't need to know how to construct or configure the logger. It just receives it and can start using it right away. But if myService doesn't construct the logger, who does it? Well, ASP.NET Core provides the iService provider, which is what is known as the service container. Your application can register myLogger and any other dependencies with iService provider during startup, which is typically done in your program.cs file. Then later, when a new HTTP request arrives, and your web app needs an instance of my service, the service container will notice its dependencies and it will go ahead and resolve, construct, and inject those dependencies into a new instance of my service via its constructor. This enables multiple benefits for your application. To start with, my service won't be affected by changes to its dependencies. It doesn't matter how many times the constructor of my logger changes, there is no need to change my service. Moreover, my service won't be creating instances of my logger, so it doesn't need to know how to construct or configure it. If your application uses minimal APIs, dependencies can also be injected as parameters to your minimal API endpoints. Finally, dependency injection opens the door to using dependency inversion. But what is dependency inversion? The dependency inversion principle states that code should depend on abstractions as opposed to concrete implementations. Let's bring again our myService class and its myLogger dependency. Currently, my service depends directly on my logger, which allows it to write logs to an output file. But let's say that now we're moving to the cloud, and we need to start sending logs to some sort of cloud service. For this, we would like my service to start using a new Cloud Logger class. We could modify my service to receive and use a Cloud Logger instance instead of a myLogger instance. However, what we can do instead is modify my service so that it depends on a new iLogger interface instead, which provides all the required logging functionality. Then we can have both myLogger and Cloud Logger implement this new interface. With this, we are decoupling my service from the logger dependency, allowing it to use myLogger, Cloud Logger, and any future logger implementations without ever having to modify my service. The only thing that the different loggers need to do is to implement the interface that my service depends on. In terms of the code, this is how you would now inject the logger into my service. So the main benefit of using the dependency inversion principle is that dependencies can be swapped out without having to modify the class that uses them. But also, it is now much easier to test my service, since the logger dependency can easily be mocked out or stopped. And finally, your code is now cleaner, easier to modify, and easier to reuse. Now, before we start using dependency injection in our code, there is one more important concept to understand, which is the service lifetime. We now know the basics of dependency injection in ASP.NET Core. We know that on startup, your application will register the dependencies, like my logger here, and later, when an HTTP request arrives, iService provider will resolve, construct, and inject an instance of my logger into a new instance of your class, my service in this example. What is not clear is what happens when a new request comes in. Should iService provider create a brand new myLogger instance for the new request? Or should it reuse the same instance? What if another service that also has a dependency on myLogger needs to be created in response to a new request? Same myLogger instance or new myLogger instance? The answer to this lies in the service lifetime, which you configure when you register myLogger with iService provider. There are 3 available service lifetimes, so let's take a look at each of them. Let's say that myLogger is a very lightweight and stateless service, so it's okay to create a new instance every single time any class needs it. In that case, you would register myLogger with the addTransient method. When the first HTTP request arrives, the iService provider, as usual, will resolve, construct, and inject a new instance of myLogger into my service. However, when a new HTTP request arrives, iService provider will construct and inject a brand new instance of myLogger, which has nothing to do with the first instance. Furthermore, if there's any other service that participates in any of these HTTP requests and also has a dependency on myLogger, it will also receive a brand new instance of it. So, transient lifetime services are created each time they are requested from iService provider. What if myLogger is a class that keeps track of some sort of state that needs to be shared across multiple classes that participate in an HTTP request? In that case, you would register myLogger with the addScoped method. Here, when an HTTP request arrives, the iService provider will again resolve, construct, and inject a new instance of my logger into my service. But if there's any other service that participates in that same HTTP request and that also has a dependency on my logger, it will receive the exact same instance of this dependency. However, if a new HTTP request arrives, the service container will create and inject a brand new instance of my logger instead, totally unrelated to the previous instance. So, scope lifetime services are created once per HTTP request and reused within that request. Finally, let's say that my logger is not cheap to instantiate, and it keeps track of a state that should be shared with all classes that request it during the entire lifetime of your application. Then you would register my logger with the addSingleton method. As usual, when an HTTP request arrives, the iService provider will resolve, construct, and inject a new instance of my logger into my service. And if there is any other service that participates in that same HTTP request and that also has a dependency on my logger, it will receive the exact same instance of this dependency. But furthermore, if a new HTTP request arrives, the service container will once again provide the same instance of my logger to any of the classes that request it. And it will keep doing so until the application is shut down. So, singleton lifetime services are created the first time they are requested and reused across the application lifetime. Now that you understand dependency injection in ASP.NET Core and the different service lifetimes, let's get back to the code and see how we can use these concepts to use a DB context across our API endpoints. We just learned about dependency injection and service lifetimes, but how are those related to our DB context? Well, going back to program.cs, let's look at this line here, line 7, builder.services that add SQLite with GameStore context. This line is actually registering our DB context, GameStore context, into the service provider, which is a service container, and it is doing so with an scope lifetime. So it may not be evident here, but when you see this line, what's really happening underneath at some point is something like builder.services that add scoped with GameStore context, right? And there's of course more going on than just this, but this is the key part. So GameStore context is getting registered with the service provider so that later on, anywhere in our code base, we can go ahead and inject that instance of GameStore context into our code so that we can take advantage of its services. Now, why is this GameStore context registered with a scope lifetime? Well, by doing a scope lifetime, this ensures that a new instance of the DB context is created and disposed for every single request. And this is important for a few reasons. Like, for instance, database connections are limited and they're a relatively expensive resource. So by having the DB context registered as a scope lifetime, that ensures that the connections are opened and closed efficiently. Also, DB context is not thread safe. So having a single instance of DB context across multiple requests would lead into concurrency issues. So we don't want that. We also have to think about transactions, right? So having a separate DB context instance per request makes it easier to manage transactions and ensure data consistency across a single unit of work without interference from multiple requests. And finally, reusing the same DB context instance across multiple requests could lead to increased memory usage because the DB context keeps track of changes to entities over its lifetime. So by having a scope lifetime, that ensures that the DB context is short-lived and reducing the memory overhead and potentially improving performance. All right? So now that we understand that our GameStore context is getting registered as a scope service, we can start taking advantage of it across our code base, okay? So let's just go ahead and remove this line and let's put this as it was. And what we can do now is go back into our endpoints. So endpoints over here, games endpoints. All right, let's collapse this and close that. And we can now go back into our post endpoint. Let's start with post, this one over here, which is the one that's going to allow us to create a brand new game. So as you remember, the only thing that we're receiving right now in the handler for this method is the DTO, the new game DTO. So now we're going to go ahead and inject the instance of game store context that has been registered in the service provider. So for that, all we have to do is just add game store context, db context. All right. So at runtime, ASP.NET Core is going to take care of resolving and providing us an instance of that context right here without us having to do anything else. And so from here on, we don't need to be creating these DTOs manually as we're doing it here. Instead, what we want to do is to start creating entities into our DB context. So here's what I'm going to do. So I'm going to say it's going to be just of type game equals new. Okay, and now I'm going to do control dot here so we can import our GameStore.api.entities namespace. All right. And here is where we're going to be declaring all of the properties of our brand new game. Okay, and let's start with the name. So name is going to be new game.name. And the next one is going to be the genre, right? So we want to assign a genre here. Now the problem is that if we go into new game dot, we're going to notice that currently the genre that we have in this new game, in this DTO, and I'm going to do F12 or here on genre to see once again the definition of our create game DTO. The problem we have is that genre is just so far a string. But this is no longer going to really play well with our scenario because think about it. Our client is likely not going to send us the string corresponding to the genre. Likely the client will send us the ID, the unique identifier of this genre, so we can create it into our data model, right? But so far, this is just a string. So we need to change our DTO at this point so that we can receive the proper ID of the genre. Let's go ahead and change this, right? So let's go and do genre ID, all right? And with that, let's go back to games endpoints. And now we can actually assign a genre to the game. Now, what genre will be assigned? Because this is an actual entity, right? So to do that, what we're going to do is just say db context that genres that find, and we're going to say new game dot genre ID, right? So with that, we are actually taking advantage of the db context to find the instance of genre that matches that genre ID, and then we're going to assign that into our genre in the entity. But also remember that we also have a genre ID property in game itself. So we should also assign this to new game.genre ID, right? And then just go with the price, which is new game.price. And finally, the release date, which is new game.release date. Okay, so that is the creation of our entity. And then we have to go ahead and add this brand new entity into our DB context. And to do that, we can do DB context dot games, the games DB set, and then you can say just add, and then we will put here the game, right? That's what you have to do to add it to the DB context so that entity framework and the DB context can start keeping track of this brand new entity that will need to be stored into the database. Another way to do this could be to just remove games and just say .add. That should work too. But I prefer to use games just to be a bit more explicit to tell where exactly this game entity is going to go. Lastly, what you also have to do is just say db context dot save changes, right? Save changes is the method that's going to actually transform all of the changes that have been tracked by entity framework so far, in this case, the addition of the new entity. It translates that into whatever SQL statements needs to be executed into the database to insert the new record into the games table in this case. All right. And that's really all we have to do to transform our post method into a method that's going to actually work with our database. And so let's see how this works in action. So let's go ahead and open our terminal. I'm going to do .NET run. All right. Let's go into our games.http file. Let me close this for a moment. And we can go ahead and create our very first game. Now, one thing that we'll have to change in this post that we have here is that, as you know, we are not sending the genre as a string anymore. We are sending the ID, right? So this has to be genre ID now. Now, what ID are we going to use in here? Well, we have to remember what ID we're using when we create the genre. So if we go back into data, game store context, remember that here is where we declare statically which are the genres to be populated into the database. So in this case, well, for Minecraft, we're going to be using kids and family. And this is ID number 5, right? ID number 5 over here. Okay, so let's close this and let's go back here and let's just put number 5 over here. 5. And with that, we're ready to send the request. So I'm going to just right click here. I'll do send request. And as you can see, we are getting a validation error, which makes sense because the price cannot be more than 100. So let me actually fix that very quickly. For Minecraft, it's going to be just $19.99. Let's once again right click, send a request, and the record has been created, right? We can see that Minecraft got created over there. It got assigned ID number 1 by the database in this case, ID number 1, and everything is looking as it should for our brand new Minecraft game. Okay, and of course, what we want to do now is verify that this actually exists in the database right now, right? Which it should, but let's confirm that. So let's close this, and I'm just going to stop my server for now. Control C to stop the server, and let's go back into our SQLite Explorer. Let's right click on games, and I'm going to say show table. Okay, so if we put this on the left side, we're going to see that, yep, indeed, our brand new game, Minecraft in this case, has been created into our SQLite database, right? So that seems to be working properly. Okay, so that's great, but there's one thing that is not working as it should, and perhaps we should notice that much better. So let me close SQLite. And yeah, we didn't see that, but let me go ahead and rerun our server. And just for fun, let's create Minecraft once again. And let's see, I'm going to hit send request. So notice on the right side that something changed here, right? Because the response that we were sending back to the client before did not include this composed generate object with an ID and a name. If you remember, before we were returning back here for the response, just generate as a string, right? So by doing what we're doing here right now, we have changed the contract of the response back to the client, and we should not do that, right? We should respect the contract we were using so far. We have indeed changed the contract for the inputs, right? Because that makes sense, right? So now we have to, the client has to send a general ID, and that's fine. But we should not be changing the contract of the response back to the client. So what can we do to keep the contract as it was before, right? That we should understand how to do that. So let's go ahead and close this, and let's now stop our server. And let's go back into games endpoints. So really what we should do here is instead of if you remember, we're returning this game right here, which is the actual entity, which we should really never do. We should not return internal entities back to the client. We should always return our DTOs or data. So what we're going to do is transform that game into a DTO, right? So that can be returned back to the client. So we're going to go over here, and we're just going to say, okay, so game DTO equals new, and then we're just going to be filling in the properties. So game.id, game.name, game. In this case, genre.name, game.price, and game.release date. Now there's a warning here that says that, hey, this genre property might be null. So is that okay? I mean, it's a possible null reference. Now we know from the fact that because we are doing over here, up here, remember that we are filling it with the right value for the genre, right? And the genre must exist. Because if it didn't exist, we're going to get some sort of foreign key related exception when we try to save the game, right? So if we manage to get to this line over here, it means that we indeed have a value for genre, right? So it cannot ever really be null. So because of that, we're going to be using the null forgiving operator. So this exclamation mark over there to say, hey, I'm going to tell you that genre is never going to be null at this point. So you will be able to access the name property just fine, right? And with that in place, we can now return, instead of the game, we're going to be returning game DTO, just like that. Okay. And so with that change, let's go ahead and rerun our server. All right. And let's go back to games HTTP. And let's see if we can create a different game. Let me just grab another game here from my other screen. Let's create a different game. It's going to be Street Fighter 2. As you can see there, we generate ID 1. And let's go ahead and send a request. And as you can see on the right side, so the game got created just fine. It got ID 3, which makes sense. But more importantly, if we scroll down, we're going to notice that the genre now is back to what it was before. It's just a simple string. That's what we're returning. Even when the input includes the generate ID, as you can see there. It's just the generate ID, but the response is generate. So that's a way that we can keep that contract with the client even when our internal structure has changed, right? And this is why it is very important to keep that separation between DTOs and the data model, because the DTOs is a contract with the client which you must keep at all times, but your internal structure can change at any time. And you want to have that flexibility all the time. All right. So let's close this and let's stop our server. Now, if we go back into our code, games endpoints, one thing that we're going to notice is that, this method just got too big, right? There's too much going on here. Like we have to create our entity out of the new game, create a game DTO, and then we store it into the database. And then we have to, once again, create a DTO out of the game entity to return it back into the client. So to simplify things a little bit here, what we want to do is to have some sort of mapping logic, right? I mean, the logic is there, but we want to extract the mapping logic into some other class that can take care of this for us, so we don't have to see so much code just in this method, right? So we need some refactoring here. So there's a couple of things that you can do at this point. I mean, of course, a way to deal with this is to use a mapping library, like for instance, Automapper is a very popular choice to automatically map all of these fields from the entity to the DTO and from the DTO into the entity. So that's one possible option. And if that works for you, that's totally fine. But in this case, since we only have very few properties, what I'm going to do instead is a simple extension method, right? That is going to help us to do this in a very explicit way, and it's very easy to understand. So just keep in mind that you don't need to go all the way into a fully fledged library just for this little mapping here. I would only start thinking about such a library if the scenario is really complex, right? And if I have tons and tons and tons of properties I need to map, and I have multiple entities and DTOs and all that, maybe in that case. But in this case, it's very simple. There's no need to introduce something like Automapper. A simple extension method should be good enough. So let's go ahead and open up our Explorer here. Let's collapse this. Let's go into Solution Explorer, actually. So we can go ahead and create a brand new directory. Just under GameStore.api, let's right-click, new folder, and let's name this mapping. And in that mapping directory, let's right-click and add a new file. It's going to be a class, and let's name it game mapping. All right, collapse this. Let's fix the namespace, control dot in the namespace declaration to change namespace to GameStore.api.mapping. Now, since this class is meant for extension methods, once again, we make it a static class. And we're going to create a couple of methods. The first one is going to map a create game DTO instance into a game entity instance. So let's create public static. It's going to return game to entity. Okay, so this is extending create game DTO, new game. All right. And I guess we can just call this one game, like that. Okay, so what should we have here? So if you go back to games endpoints, we want to have something like this, right? This logic over here. So I'm going to copy this into game mapping. I'll paste that here. Now let's scroll down a bit. And what we're going to do is just say return new game. Okay, and let's fix things a bit here. So this is going to be just game.name. Now for the genre, we cannot actually access the DB context from here, right? So we're going to keep doing that back in games endpoints. So let's remove this because we're not going to be sending the DB context into this method. We only care really about the DTO. Okay, and then for gener ID, we have game.gener ID. Then we have game.price, and then we have game.release date. All right, so that takes care of the first method. And then we want to create a brand new one down here. And this other one is going to help us map a game entity back into a game DTO. So public static game DTO to DTO. So we're going to be extending game entity right there, like that. Now, what are we going to return here? So going back to games endpoints, we're going to be returning what we do over here. So let me copy this section down here. Okay, and all we have to do really here is just say return new, and yeah, that's pretty much it. That will return a brand new game DTO. Awesome. So with these new extension methods ready, we can now go back into games endpoints and take advantage of them, right? So let's go back first here where we are creating our new game instance. So instead of that, what we can do is say game equals new game dot to entity, just like that. But we still have to account for the genre entity that needs to be attached into the game. So because of that, we have to still do game dot genre equals, and that's going to be this line here, line 59. We have to copy over there, right there. But the rest we can get rid of now. So this can go away. And one more thing. So now for the game DTO, we can actually just get rid of this entire section. Let's get rid of that. And here, what we can say is at the very end, and let me actually send these parameters to the next line so we can see better, like this. Okay, instead of sending game DTO, we're just going to say game.toDTO. That's all it is. All right. Now let's make sure that this is still working properly. So let's open up our server, our terminal, and let's run our server over here. Okay, the API is running. And let's see if we can create a brand new game. So let's go ahead and create a new game that I'm going to populate over here from my other screen. So let me replace this with that. Okay, it's going to be the Final Fantasy 14 game with generate ID 2. So let's right click, let's send a request. Yep, and as we can see on the right side, it got created and it got assigned the proper genre here, which is role playing, right? It has the ID. So yep, the mapping is working as expected. All right, let's close this. Perhaps let's also close this over there. And let's get back to games endpoints. With our post endpoint ready, let's move on into the next endpoint, which in this case is going to be our get endpoint, get by ID actually. So let's see what we have to do to make this endpoint start using our DB context. So of course, first thing to do is to receive the DB context as a brand new parameter in the Lambda, right? So let's go ahead and add game store context. It's going to be our DB context right there. Remember that this is injected via the DI engine, dependency injection, into our method at runtime. And now what we want to do is just change this line so that it uses the context and the game entity instead, right? So for that, we're going to just switch this into just game. And then here we're going to say, instead of that, db context dot games dot find, and here we can pass in just that ID, like that. So that's how you can quickly find the entity inside the DB context. Now, keep in mind that this find method is going to try to find the game within the current set of games that are in memory right now, already pulled in via the DB context. And if I cannot find them inside the DB set, the current DB set in memory, it will go ahead and find it in the database if needed, right? So it's a very efficient method. Now, one thing that we need to realize is that, of course, we don't want to just return the game, right, as we are doing right now. Like we said, we don't want to return the data model, we want to return a DTO. But what DTO will we return? If we go ahead and return, like we did in post, if we return with toDTO, game DTO, that's not going to work very well. That is because, and let's just go ahead, and I'm going to do Control P here to take a look at game DTO. So game DTO, here. We will be returning this, and this is going to include the genre as a string. However, for a getById method, we don't really want to return the genre as a string. And that is because the client would likely want to have the genre ID to be able to use it in the UI, right? Imagine a UI where the user is going to be selecting a genre from some sort of dropdown list, right? And so that dropdown list will have to match the genre ID that was returned by us. But if we just keep returning the string, that's going to be just too complicated, right? So the string is going to work just fine if the client is going to have a summary of all the games, right? That's fine. But if we want to see just one game, what we really want to return back to the client is the genre ID. So because of that, what we're going to do is actually to create a brand new DTO that is going to have that ID. We're not going to modify this game DTO, but let's actually create a brand new one that we're going to name a game details DTO that's going to have the genre ID that can be used by our brand new getById endpoint. So let's go ahead and open up our Explorer, Ctrl-Shift-E. Let's go into DTOs. And actually, to keep things simpler, let's go back into our File Explorer or here. And let's just copy game DTO. Let's make a copy of this one. And just right-click on DTOs, paste. Okay, because it's going to be super similar. So let's name this one game details DTO, just like that. Game details DTO. Okay, so game details DTO, let's rename that over here. This is DTO, and like I said, this is not going to have a string genre, it's going to be an int genre ID. Okay, so that's game details DTO. Now, since we are renaming game details DTO, we are creating game details DTO here, it will make sense to also rename this game DTO to give it a more proper name, right? So this is no longer going to be just game DTO. Let's rename this one into game summary DTO, right? To more clearly reflect the fact that this is a summary of the game that includes a genre as a string and not an ID. Okay, so this is going to be game summary DTO. Now, of course, this is going to cause a little bit of trouble. So let's go back into our game mapping and let's make a few changes, right? So here, where we have two DTO, this is going to return actually a game summary DTO. And let's also rename the method itself so that this is going to say to game summary DTO. Okay, that's what we should be returning from this method. But also we want to here introduce a brand new mapping method to return a game details DTO. So let me just copy this method quickly. Let's scroll down and let's paste it down here. Let's change the type here into game details DTO. And this is going to say to game details DTO, right? And here, of course, is going to be, we were going to be returning game.generate ID. All right. And with that in place, let's go back into our game's endpoints over here. And we may have to fix a few things before doing anything else. So in this list, this list is going to go away soon, but for now, just to avoid the compilation errors, let's change this into game summary DTO. Then let's scroll down over here. This is our post method, map post. So this should return now to game details DTO, right? That's what would make most sense to the client, right? Instead of returning that genre as a string, it will make most sense to the client to stick to just the ID, right? To the ID of the created genre in the game DTO. So to game details DTO. So yes, we are breaking the contract here, but let's say that we have come to an agreement with the client that this is going to be the final way that we're going to be returning that created game from the post. Okay, so game details DTO. Now let's keep scrolling down. Let's see what else we have here. This should be game summary DTO. Okay, so that fixes all of our errors there. And then one more thing that you want to keep in mind here is that since we are going to be returning really only the details, right? The game details DTO, and which, if you remember, let's go back to game details DTO. It does not include the genre as an actual object, but just the genre ID. Because of that, back here, we no longer need to assign the genre over here with this line here. There is no need because Entity Framework will take care of properly assign the genre into the game's table. It will assign the genre ID. We don't need to populate that for the game entity. We were really only doing that because we needed that later on for the mapping, but really it's not needed anymore. And now let's go back to what we were actually trying to do here, which is in map get by ID. What we want to do is instead of returning results.ok with the game over there, and let me send this to the next line so we can see better. We're going to return game.toGame details DTO. All right. And so with that in place, let's go ahead and run our API. It's actually running already. So let's stop it, clean the screen, and then .NET run. Okay, let's close this. Let's perhaps close these two DTOs. And let's go back to games.http. I'm going to put this at the start. And so what I'm going to do, just to test our brand new method, is to query for one of the existing games. So I'm going to use our second request here to get a game by ID. I'm going to right click and I'll hit send request. And as expected, things are working properly, right? So we are getting our 200 OK. We are getting our Minecraft game here, and notice that we are getting, instead of the game string or the name of the genre, we are getting the ID of the genre here, right? In this case, it's genre ID 5. Like I mentioned, likely the client is going to use that ID 5 to match it to one of the genres that it is displaying on the screen, right? Imagine some sort of drop down. So it will use this to just select that genre in that screen, right, for our user, right? So that's what we want to get in that case. And it's working as expected. Awesome. So that will take care of get by ID. Now let's go back into games endpoints, and I just stop the server. let's now work on our put operation. Let's go down here into put. Now, of course, the first thing that we should do about put here is that we need to change our update game DTO so that it can also use a generate ID and not a generate string. So let's go back into Explorer. Let's go into update game DTO. And we're going to be doing the same change that we did for create game DTO. So instead of the string here, we're going to say int generate ID, like that. And because of that, now we have to go into our mapping to also define some sort of a method to do the mapping between that update game DTO and the entity. So let me go ahead and actually copy the very first method. Let's just copy this. And I'm going to just open a space here, that copy. And now we're going to be mapping not create game DTO, but update game DTO, right, into the game instance. Now, one thing that we want to also do with update, it is not just to map the update game DTO, but we also need to account for the fact that this update game DTO does not come with an ID, right? Remember, update game DTO does not have any ID, but we do want to create this game with an ID because the user has specified that he wants to replace a very specific entity with a specified ID. So because of that, what we can do is just to add one more parameter here. That's going to be int ID. And then we'll use that ID as the ID of our return game entity. So let's assign it over here, ID equals ID. Okay. Now, how do we use this toEntity method back in our endpoint? So let's go back into games endpoints. And here we're back in our put method. Okay. So the first thing to do is to change this code here that is currently looking into our old games list. And we need to make it so that we find the existing. So to do that, all we have to do is the following. Let's do var existing game is going to be db context. And of course, we have not injected that db context into update. So let's make sure that we do that first. So game store context db context, right? We have now injected that into our map put, and we can take advantage of it, right? So db context dot games dot find, and then it's going to receive that ID. Okay. So now we are finding the existing game, and if it does not exist, it will just return null, right? We'll get a null value over here. So what we can do now, instead of this comparison, is that we can say if existing game is null, then we are going to, again, just return not found. So that stays. Okay. But then we go into the interesting part, right? So how do we actually perform the update? Well, we have to do a couple of things. First, I mean, of course, we're not going to be doing this logic anymore here. There. What we want to do is to locate the existing entry inside our DB context and replace it with the brand new entity that we are creating here. So to do that, we're going to do the following. We're going to say DB context that entry, and entry is a method that you can use to locate the current entity inside that DB context, right? So for this one, what we can do is just say existing game, right? And for inside that, we can say current values, right? So that pulls out the current values of that entity. And then right there, we're going to say set values, okay? And for set values, we can specify the new entity that's going to replace all of the values of the old entity. So here we're going to bring in our updated game, but the updated game is just a DTO. So what we want to do is just transform this into a toEntity with a brand new extension method that we use, toEntity, and passing in that ID. Okay, and that is how, with this just one line, we can go ahead and replace the existing entity with a brand new entity that comes from the DTO. Right? And last thing we want to do here is to always do db context dot save changes to make sure that the changes are sent back to the database. All right. So that's really all we have to do for the put endpoint. So make sure that this is working. So let's go ahead and run our server. Okay, I'm going to collapse this back to games.http. So which game are we going to actually update, right? So it's a bit hard to tell right now because we have not updated our get all logic, right? We cannot use this. This is still looking from the list. So let's take a quick look, sneak peek into the database to see what we have so far. So SQLite Explorer, right click on games, show table. Okay, so let's put this over here so we can see better. Okay, so these are the games that we have so far. So let's say we're going to update our Street Fighter game here, which has ID number 3. Street Fighter 2 with ID number 3. So let's close this. Let's close that. And we're going to go down here. Okay, I think we have most of it, but we don't have the name. So let me actually complete this very quickly with something that I have in my other screen over here. And what we're really changing here is that Street Fighter 2 is now no longer going to be just a Street Fighter 2. It's going to be Street Fighter 2 Turbo, right? It's Turbo, and the price has changed. So game was number 3. So let's switch it to number 3. And let's go ahead and right click and execute our request. So send request. And we do have a problem here, and that is because we forgot one small thing, which is the genre, right? So genre should not be like that. It should be genre ID. And the ID of the genre for Street Fighter should be 1 over there. And let's right click and send a request. There you go. So we got the expected 204 no content, meaning that this was a success. So, and to confirm, of course, we can go ahead and just query for game number 3 by using our get by ID request over here, right click, send request. And as we can see, indeed, we are now using Street Fighter 2 Turbo and the price has changed. So the update operation is working as expected. Awesome. So now let's just close this and let's stop our server. All right. And let's go back into games endpoints because now it is time to change our get all operation, right? So we can actually start querying for all of the available games. So let's go all the way up here into our map get operation. The first one that we have in our endpoints is this one over here. So how do we deal with this, right? So we no longer want to use the games list, but first thing that we have to do as usual is receive our game store context instance here, db context. Okay, and then let me send this to the next line to see what we want to do. So of course, we don't want to return games. What we want to do is the following. We want to say db context dot games, and then from those games, we want to transform each of those game instances into the corresponding game summary DTOs, right? So to do that, what we're going to do is use a projection by using the select method from link in C#. So dot select, right? So for each game in this games collection, we're going to say game dot to game summary DTO, just like that. And well, technically that's all we need to return our list of games as game summary DTOs back to the client. But there are a couple of other things that we want to do here. The first thing that you want to realize is that to game summary DTO, if I just do F12 here, I'm going to do F12 to go to the definition, is that we are going to need the genre property right here, right, to pull out the name of the genre. And the way it is right now, so let's go back here. The way this method is right now, it is going to only pull out the games, but not the attached genres, right? So the genre is going to come empty here. So we have to do something to also include the attached genre property for every single game. And that is, if we just open up a brand new line here, is this include method. So include, where we're going to say, okay, so for each game, make sure that we bring in game.genre, right? If you don't do this, then this genre property is going to be empty. It's going to be null when we pull out the games, and we're not going to be able to do the proper mapping into to game summary DTO to attach the genre name into the DTO, right? So that's very important in this case. And the next thing that we also want to do here is a bit of an optimization, right? Because by default, Entity Framework is going to keep track of every single entity that we're pulling out of here. It's going to do change tracking for every entity. And if you have many, that's really wasted resources, right? We don't need to keep track of anything here because we're just going to return that back into the client right away, just one operation. So we're not going to be performing any updates into the return entities. And because of that, one very good optimization I should always do in these cases is just to say as no tracking, like this. By doing that, you're saying, hey, Entity Framework, I don't need to do any tracking of the return entities, just send them back into the client, in this case, as is, right? So that's going to improve the performance of your operation over there. Okay, and so, yeah, that's all we have to do for the get endpoint. So let's test this quickly. Let's do .NET Run. All right, let's go back into HTTP. And now we can use our very first endpoint over there. So let's right click, send request. And as you can see on the right side, now we are getting the actual games from the database. In this case, Yeah, we do have Minecraft duplicated here because of what we did initially. Well, we're going to deal with that later. But we do have out of our, I guess, 1, 2, 3, 4 games declared into the database right now. Okay, so that is working properly. And notice that for each game, we are returning the generate string and not the generate ID, which is what the client would expect to display a summary view of all of the available things. All right. And so one more thing to do here is to deal with the delete operation, right? So let's go ahead and stop our server. Let's go back into, well, let me close this and let me close that mapping. And let's go back to games endpoints and let's go now into our delete operation, which is actually the simplest to implement. So as with all of the other endpoints, first thing to do is to introduce our game store context via dependency injection, db context. And then we have to change the way that we perform our removal of the entity. So how will we do this? So there are a couple of ways to do it, but the most efficient way is to do the following. We're going to say db context dot games dot where, and this where is going to be so that we can select which is going to be the one entity that needs to be removed. So that entity is going to be game where game.id equals ID. So that selects the game that we want to remove. And let me actually send this to the next one. And then when it finds that game, what we want to ask it to do is to use to execute delete. All right. So this syntax here to perform the delete is known as batch delete. And it is a very efficient operation because we don't have to first find the entity just to say, hey, entity framework, keep track of the fact that I'm going to delete it and then go ahead and save the deletion. So this one line here in one shot is going to go straight into the database, find the entity and delete it right away. So there's no need to do anything else here. And then we just return no content. And that's all it is. Okay. So let's see if this actually works. So let's go back again into the terminal. Let's run the server back to games HTTP. And so if we remember, if we right click at the very first request here, we do have 4 games, right? So since we have this one duplicated, so we have Minecraft 2 times here, let's see if we can go ahead and remove the second entry of Minecraft. So ID number 2, right? So let's close that. Let's go down here at the very end. And yeah, our delete operation is actually looking at game number 2. So let's ask it to remove game number 2. So let's right click. Let's do send request. And it seems like it was a success. 204 no content means that it succeeded. So if we go back into our full list of games, let's right click here, send request. And let's see what happened. So we have ID number 1, but we no longer have ID number 2. As you can see, there's no number 2. It is gone. So the operation was a success. Awesome. So let's just close this and then stop our server. Now, one more thing to do here before moving to the next topic is that, well, we finally no longer need any in-memory list of games, right? So finally, we can go back here and we can get rid of this entire list of games. So let's go ahead and select all of this and we can get rid of it. So now it is gone. Okay. So with that, we have completely moved into a REST API that is ready to interact with the database, both for querying entities and also to create, update, or delete all of these entities. So that is working properly. But there is one more concept that we need to also learn and apply into a REST API, and that concept is the asynchronous programming model. So let's switch slides so that we can learn more about the asynchronous programming model and why it is so important. To understand asynchronous programming, let's go through a common scenario you might be familiar with, which is making breakfast. Let's say you start by heating your pan for a few minutes, and then, when ready, you fry some eggs there. We would also like to have some bread for our breakfast. So after your eggs are ready, we bring up the toaster and toast our bread. Then, when the bread is ready, we add some jam or peanut butter on it. Finally, our breakfast would not be complete without some juice. So let's pour in some orange juice. In total, it took us about 30 minutes to complete our breakfast. But is that really how you would go about preparing your breakfast? If it is a weekday, when you are usually in a rush, perhaps you would like to do something like this instead. You start by heating your pan. And while that happens, you will also start toasting your bread. And while those two things happen, perhaps you can also pour your orange juice. Eventually, when the pan is ready, you go back to it and fry some eggs. And once the bread is toasted, you go and put the jam or peanut butter on it. Doing things this way, you can be done in much less time, say 15 minutes, and perhaps you can spend the rest of the time enjoying your breakfast. When comparing these two ways going about making your breakfast, we say that the first approach is synchronous, since you won't start a new task until the previous one is complete. However, the second approach is asynchronous, since you don't wait for a task to be complete before starting your next task. Instead, you start as many tasks as you can, and eventually you turn your attention to tasks that are ready for you so you can continue with the next task. In a similar way, you can perform asynchronous programming in your ASP.NET Core applications. When a client sends a request to the web server, you want to start handling the request in your endpoint in an asynchronous way, so that your cook, the Kestrel web server, is immediately free to start handling the next request. So as your endpoint starts an asynchronous call, perhaps to your DB context, and the DB context in turn requests data asynchronously from the database, the web server has also started serving the next request, also asynchronously. When the database eventually returns the requested data, the DB context will resume work and send the data back to the endpoint, which in turn resumes work, transforms entities into DTOs, and sends the data back to the web server, who in turn responds to the original client request. After this, the application continues starting other tasks asynchronously and resumes work whenever necessary. As you can see, the asynchronous programming model brings in multiple benefits. Your application gets improved performance since you avoid blocking callers and free them up to perform other tasks, which also results in overall better responsiveness. You are able to scale your application better because it can handle more requests and users simultaneously without getting bogged down by waiting for I/O operations to complete. And also, the use of task objects in combination with the async and await keywords provide a simple and intuitive way of writing asynchronous code as opposed to having to deal with threads and callbacks directly. Now that you understand the asynchronous programming model and its benefits, let's see how to put it to work in our current REST API. Taking advantage of the asynchronous programming model in our .NET REST API is actually very straightforward. So here we're back in games endpoints, right? And so we're going to see how to introduce this auto model in each of our endpoints. And let's start with our map get endpoint here to retrieve all of our games. So the first thing that we want to do is to modify a little bit the way that we talk to our database or to our DB context so that when we ask it to return the games, it does not just return the games, but instead of that, it is going to return a task that can be awaited until the operation actually completes. That way, ASP.NET Core does not have to block on the operation until it is done, right? So anything that goes out of your process, like going into the database, going to the file system, going to the network, all of those operations, we want them to return just a task that can be waited and that can be resumed later on when the operation completes. So in this case, really all we have to do is just to add one more call at the end here to transform the output games into a list in an asynchronous way. So we're going to say to list async, right? And so that's going to now return, as you can see, it's going to return not just a list. So notice this. This returns, okay, so let's open up this. This returns not just a list, but it is a task of list, right? So because of that, the runtime can wait for that task and it's going to resume when the games actually come back from the database, all right? And you're going to notice this convention where you use the async suffix, this suffix over here, for every operation that is going to return not the actual object, but just a task that includes the results of the operation, right? So many libraries, you're going to notice that they use this convention, so prefer these asynchronous methods when you invoke these kind of APIs, right? And you should also be using this same convention if you write your own asynchronous methods, right? So that works But the other thing that you also want to do is to use the async await combination of keywords for your own method. Now, in this specific method here, it may not be absolutely necessary because it's just a one-liner here. So arguably, maybe you don't need to use that. But just for convention, just to keep things safe and simple to understand, let's go ahead and add async and await here, right? So we're clearly signaling the compiler that it wants to execute this as an asynchronous operation and that it needs to await for the task here to complete before returning the data back into the client. Now we can follow this same convention across all of our methods to make sure that all of the operations work in an asynchronous way. Okay, so let's go down into map get to get a game by ID. And just like we did in the previous method, we're going to now transform this into an async, right? So now it's an asynchronous operation, and we need to await every single operation that goes outside of our process, right? In this case, that's going to be this line here where we go ahead and find the game. So we're going to say await, all right? And so, but of course, find, it is not an available method. It's just a simple find method that we need to now transform into find async, just like that. All right, so now, just like in the previous method, ASP.NET Core is going to start a task to find the game, and it's going to go back to it when the game is actually retrieved from the database. Let's move on into our post method now, which once again is going to be an asynchronous operation. And then what is going to be the actual operation that we need to wait for? That's going to be our save changes. So this is the only operation that's actually going to go outside of the process to save the data back into the database. So we're going to say await, and this is going to be save changes async. Okay, now let's keep going down into our put operation, which we're also going to turn it into an async operation like this. And here we have a couple of asynchronous operations. The first one is going to be the one here to find the game, this one in line 53. So this we should await, and then find async, right? So now we can find it in a synchronous way. And then we go all the way down into save changes. And again, we want to do await, save changes, async. Finally, let's go down into our delete operation, which again, we're going to make it async. And then the operation that we want to wait here is the execute delete over here. So remember that this goes straight into the database to perform the deletion. So we're going to say await and then execute delete async. All right. And well, that really takes care of all of our API endpoints. Now everything going on in this endpoints class is really asynchronous. But there's one more location where we should also take advantage of the asynchronous programming model. And that is the location where we perform the migration when we start the application. So where is that happening? Let's go back to Explorer. Let's collapse this. And let's go up, data extensions under our data directory, data extensions. So remember that this is the place where we eventually go ahead and just execute any pending migrations when the application starts. So this should also work in an asynchronous way, right? Because it has to go out and talk to the database. And that could take time. So what we're going to do is change this operation in a few ways. The first thing is that since we're going to be returning no longer just a standard return, but a task, right? We have to be very clear about this. So it can no longer be void. It has to be a task so that whoever calls this operation can actually await on that task. Now, we also need to follow the async and await convention, right? Because that simplifies the way that we can deal with this task. And then instead of calling migrate, we want to call migrate async. Okay, and now our method is really an asynchronous method. But remember that I mentioned that anytime you deal with asynchronous operations, you should name your methods with an async suffix. So that's a convention across the entire .NET and C# ecosystem. So just like migrate async uses the async suffix over there, you want to also modify your migrateDB method here so that it's named migrateDB async, right? Just like as a convention. And of course, since we're doing this, we have to now go back into program CS over here. And in line 13, we have to make it so that we take advantage of the brand new name method. So migrateDB async. Now notice this warning here. So this warning is alerting us of the fact that this method is asynchronous, right? because it returns a task, but we are not waiting on it, right? So if it is a task, we have to make sure that we actually await on it before moving on to the next step. So because of that, all we have to do is just say await over there, and that is going to properly wait for the task to complete before moving on to the next thing. All right. And so, yeah, that's pretty much all we have to do at this point to take advantage of the asynchronous programming model. And what I like to do to make sure that everything is working properly, including this last change, is to, well, let's go ahead and delete the database. And let's see if when we run the application, it can actually recreate that database. And then we're going to start testing our endpoints once again to make sure that everything is working properly with the asynchronous programming model. So let's go ahead and open up our Explorer. Let's make sure also that, yeah, the server is not running right now. So let's right click and delete our game store database. So delete. Okay, the database is gone. So it has to be recreated when we restart the application. So let's go ahead and open our terminal. Okay, let's collapse this. .NET run. Let's see what happens. All right. Apparently everything went properly. The migrations were applied. As you can see here, migrations got applied. We should be able to see the database back here. So yeah, as you can see, the database is back. So that worked just fine. And then let's just go ahead and test perhaps one post operation here to verify that things are working properly. So I'm going to right click here, send request. Yep, the post was a success. As you can see, the game got created. And we should be able to also query for games up here. So I right click here, send request. Yep, we can query for games. So things seem to be working just fine. And now we're taking advantage of the asynchronous programming model, which makes things much more efficient for our .NET REST API. All right, so let's go ahead and close this and let's stop our server. All right, and get back to games endpoints.cs. At this point, our games endpoints are complete. And what I'd like to do now is to show you how these endpoints can be integrated into a modern web client. But before we can do that, there's still one missing piece, and that piece is our genres endpoint, because we have the ability to fully interact with games right now, but we don't have that ability with the genres. And it's not like we need an entire API and a set of endpoints for genres, but we at least need the ability to be able to query those genres because we have some UI elements in the client that are going to need to query for those genres. So let's go ahead and apply everything we learned so far about .NET REST APIs to see how quickly we can come up with a brand new endpoint to be able to query for those genres. So let's go ahead and close all of these. So let's close all these tabs. Let's go back to Explorer. And the first thing that we're going to need is a brand new DTO, which is going to be the DTO that represents the genres. So let's head back into Solution Explorer. And let's go ahead and right click on DTOs, new file. Remember that this is a record type. And let's name this one genre DTO. All right, let's collapse this. Let's go ahead and fix our namespace. Install that API.DTOs. So fully record class genre DTO. Let's use the simpler syntax here to specify an ID and a name. All right, so now we have the DTO. Let's go ahead and define a proper mapping for transforming our genre entity into genre DTOs. So let's go into the mapping directory and let's actually spin up a brand new mapping class because this is going to be for mapping genres, right? So let's not mix that with games. So let's right click on mapping, add new file, it's going to be a class, and let's name it genre mapping. Okay, let's collapse this. Let's fix the namespace. It's going to be gamestore.api.mapping. And then this is going to be a static class because it is for extension methods. Let's define just one method, public static genre DTO to DTO. And then we're going to be extending the genre class, which is already defined in our data model. So genre. And all we're going to do here is just to return a new genre DTO with genre.id and genre.name. All right, so the mapping is ready. And then the next step is to, well, define the actual endpoints to be able to query for these genres, right? So let's go back into Solution Explorer and under our endpoints directory, let's go ahead and create a brand new endpoints class, this time for the genres. So let's right click on endpoints, new file, going to be a class, and let's name it genres endpoints. All right. So here, let's go ahead and also fix a namespace, GameStore.api.endpoints. It's going to be a static class. And let's follow the same idea as the previous endpoints class. So it's going to be a public static, and we're going to be returning a route group builder, right? Because we're going to be using route groups here. Let's name it map genres endpoints. And then let's extend our web application class app. All right. So remember that we can first create this map group this way. So var group equals app.map group. So our group is going to go into genres. All right, genres. And then let's go ahead and define just one endpoint. So group.appget. Okay, so this is going to be called just under genres. So we'll just put that / over there. And then for the handler, we're going to be using an asynchronous operation to query for those genres. So it's going to be async. And then for the parameter for the lambda, we're going to be receiving our game store context once again. Game store context, db context. And then we have to specify something to do with this handler, right? Right, so let's go to the next line. Let's close this. And here what we're going to do is just say await. Okay, so how do we retrieve all of those genres? Well, we use the db context. So db context dot genres, right? Now, if you remember, here's where we have to project the genres that are in the data model into corresponding DTOs. And we can do that easily by just going, let's go to the next line. We're going to say dot select. Okay, so for each genre, we're going to do genre dot to DTO. All right. And then remember, we also said that for this kind of operation that does not need any tracking from entity framework, and we just want to send back the genres directly to the client, we're going to say that as no tracking. And lastly, we want to make sure that this returns an async, returns a task as part of an async operation. So we're going to do to list async. Okay, and let's actually send this to the next line like that. All right, so that defines our endpoint. And last thing to do here is just to return our group. Awesome. So yeah, so the endpoint is ready. And last thing to do here is to actually take advantage of this method in our program.cs file. So this time we're going to use close Solution Explorer. Let's go back to File Explorer. And I'm going to open up my program.cs file over here. And just under map games endpoints, I can insert a brand new line. And let's just say app.map genres endpoints, like that. All right. And so, yeah, we're ready to query for those genres. So let's see this in action. Let's do .NET Run. And what we're going to need here is perhaps a new .http file so that we can add our new request for genres, right? So let me collapse this because we do have this games.http, but since this is different, so let's actually add a new one for genres. Let's just right click, add the root in the File Explorer, new file. Let's name this one genres.http. There. And all we're going to do is just say here get, and then, well, we need the actual endpoint. So remember that we have that here in a few places. So let me copy this from our other file there. And then the path is going to be under genres, right? All right, so that's it. So I'm going to collapse this and let's just right click on this and let's say send request. So as you can see on the right side, this was a success, 200 OK. And we can see down here that we are properly returning all of our game genres. So just like that, we have stand up a brand new endpoint that our client can use to get the full list of all of these genres. Awesome. So let's go ahead and close this and let's stop our server. And with that, we're ready to go to the last part of our tutorial, which is where we're going to integrate this .NET REST API with an actual client application. Now, this is totally optional because we have already done all of the backend work here, and that's what we wanted to achieve. But I also like to always see how this actually serves the purpose of some client, because there's really no point of having an API if there's not going to be an actual client for this. That's the whole idea, right? So I have prepared a small client, so we don't have to code this. The client is ready. So I'm going to open up that client in this other VS Code instance over here. I named it GameStore.frontend. This is a very simple Blazor application with server-side rendering, so nothing fancy really. And I'm not going to go over the code of this frontend here. If you want to know more about this frontend and how exactly I built it, I have another video where you can see the process from scratch, how I created this little frontend here. It's very simple really. But really all we have to do here at this point is configure this frontend to be able to talk to our API. And I have prepared a section in app.json here where all I have to do is just to enter the URL of our backend, right? So what is that URL? Let's go back into our other VS Code instance and remember that our URL is right here. So it's localhost 5274. I'm going to copy that and let's head back into our frontend and I'm going to paste it over here. Okay. So now our frontend is ready to start talking to our backend. So let's see this in action. So let's go back into our backend and let's just do .NET Run. So the backend starts, it's ready. Let's go into our frontend now. Let's do something similar, right? Since this is Blazor, all we have to do is just .NET Run. All right, so it's up and running. And I'm going to go ahead and click, and this is the URL of our frontend, right? So not the backend, but the frontend. So I'm going to just control click on that one. So this opens my browser. And as you can see, we can already list the one game that we have right now in our backend. Okay, so not much going on here. All it is rendering a simple table with the list of games. And for each game, you can see that we have buttons for editing the game, deleting the game, and there's also a button over here for creating a brand new. So let's actually go ahead and click on new game so to see if we can spin up a brand new game over there. So notice that we have this drop down list over here. And this is the list that I was mentioning that is going to go ahead and pull the list of genres for our game, right? So this is pulling from that list that we just created, that backend, that REST API for genres. That is the list that's using it, right? So let's go ahead and see if we can create a brand new game. So let's go for, let's see, Elden Ring, awesome game. So it's going to be role-playing. The price is going to be $49.99. And then let's go ahead and enter some date for this. It's going to be February 25, 2022. Right? And then let's go ahead and click on the save button. And as you can see, it went ahead and stored our game right here. Okay, and we can confirm that this actually talked to our API because we can go back to VS Code, of course, and we can take a quick look at the database over here via SQLite. We can right-click on games, show table, and we can see that the brand new game got created over here, right? So this is really talking back to our recipe. Okay, and so let's see how what we can do about an update operation, perhaps, right? And so let's go ahead and update this Final Fantasy 14 game over here. So I'll click on Edit. Let's make it so that the game is a bit pricier. So let's say it's going to be $69.99. Let's go ahead and save the game, save. And as you can see, it did save it properly without any problems. All right. Awesome. And then, yeah, before we try to delete, let's actually come up with something that we can delete and then we can keep the other games in there. So let's just save this test game here. And now I'm going to go ahead and click on the delete button over here to see if we can delete this game. And the game is gone. So yeah, there you go. So you have a REST API that can fully integrate with a modern client like this one. And I hope you enjoyed creating this REST API with me. Like I said, if you want to take a look at how I created this client, there's another video for that. But at this point, thanks for watching, and I'll see you in the next video.